Ladies and gentlemen, welcome to It's Rainmaking Time and this special segment on the truth about weather and climate. I am clear that we will not be in possession of the total truth about weather and climate for some time. But I can promise you, we will have the necessary grounding, that which is necessary to truly inquire about this subject, and we will have the tools to decipher facts from fiction. True inquiry and scientific process is actually hotter as a subject than, quote, global warming and, quote, climate change. The business of science is actually hotter than what's going on with weather and climate. And what's interesting is that they're fused. They're going on in a connected fashion, even though they're parallel things going on. It's fascinating and it's very controversial. So it's best to sit back, put on your seatbelt, relax, and think that you're flying on a starship with a passionate scientist with 20 years plus of training and loves his field. Ladies and gentlemen, Willie Soon is an astrophysicist and a geoscientist at the Solar, Stellar, and Planetary Sciences Division of the Harvard-Smithsonian Center for Astrophysics. He is the receiving editor in the area of solar and stellar physics for New Astronomy. He is the author of the Maunder Minimum and the Variable Sun-Earth Connection. He is the receiver of the Peter Beckman Award for Courage and Achievement in the Defense of Scientific Truth by Doctors for Disaster Preparedness. He is the Chief Science Advisor to the Science and Public Policy Institute. Ladies and gentlemen, welcome Dr. Willie Soon.
Thank you, Kim. It's a pleasure to be here.
I thought, because we've covered in part one of this look at climate and weather and what is this global warming phenomenon and new laws, what are they about and why is this happening and what is the true science and what is the erroneous science and what's even happening to science. I interviewed a meteorologist and another climatologist and an author of 2 books, Robert Felix, and I thought that a perspective from an astrophysicist would be useful today to distilling what is the distinct perspective an astrophysicist has on this subject of climate and weather?
Okay, that's a very good question. Let me start by saying that, first of all, we know that in terms of the energetics, the energy that is available for basically the ocean current to move or the air current itself to move or even the tree to grow, things like that, it's all essentially given by the sun. So therefore, I guess for someone who's studying the sun for a while, it would be very useful to add the perspective in terms of how, in terms of the energetics in the Earth climate system would change or varies. And then, as somebody who's been also thinking long and serious about this question, then I really think that the insight from what we have learned about what the sun has been doing in terms of how its light output has been changing over 1,000 years or even 100,000 years or even millions of years would be, of course, important in terms of trying to really get at the true understanding of how the Earth weather and climate system would work. I would start with a very simple basic, even it's actually somewhat surprising sort of a question that if you ask to the lay audience or maybe even to you, Kim, yourself, how many percent do you think the carbon dioxide in the air do we have?
I see. Before we even go to that, and that may be the question, before we even go to that, may I go back and start you a little bit more for a beginner who has no entry point, no context, no frame of reference for anything about the sun? Can we go back to that and then go back to the CO2 part?
Sure.
Okay. Go ahead. Talk about the sun, the distillation of what the sun's activity has on climate as we know it.
Yes. The sun, as we know, is basically the main energy source for all the available energy in the climate system. There is no doubt that whatever the sun does, however minute, even just the fact that the Earth going around the sun every single year produces that season. And then I would even go further and claim that a lot of the current confusion about how the weather system and the climate system work is basically caused by the lack of our ability to try to truly understand how even the seasonal cycle work. And the sun itself, of course, is not a constant light bulb, like the light bulb you have in your room, who's just shining at the constant energy source that is not changing at all. To the contrary, we, after basically 400 years of study, starting with Galileo Galilei, that we have learned that essentially the sun is the imperfect light bulb with a lot of basically stuff that is coming and going in its surface. These stuff are essentially things that are known as sunspot, for example, the magnetic sunspot, because sunspot is essentially a magnetic structure that is built on and made up in the sun itself.
Is a sunspot, I want to clarify a few things for the listener. Remember, we're establishing a frame of reference together. And so if you could help me with them, the sunspot is what? Is that the center of the sun? What is a sunspot?
A sunspot is darkened areas on the surface of the sun that is essentially, the reason why it's darkened is because of the magnetic field that is extremely strong around the region. That is close to about 10,000 times at least stronger than the average Earth magnetic field, for example. And the reason why it's dark is, of course, because around strong magnetic field region, hot gases would not be able to flow very well around there, so it sort of appear a bit darker relative to the brighter background. And the fact that we have sunspot, and then we have also basically not only sunspot, of course, the dark magnetic structure, we also have extremely bright magnetic structure as well. So these are the few of the features on the sun that actually would sort of attack a war within these features that would actually govern how much sunlight actually is given out by the sun itself. And of course, once the sunlight reaches the Earth, that would serve as the input or the energy input to the Earth climate system. And after 400 years of learning, we do find that indeed these magnetic structures on the sun, magnetic features on the sun, do change quite a bit. A bit in the sense that it is more than enough to try to explain most of the changes that we have been able to measure and deduce on the Earth climate system. Meaning that if the Earth temperature that is changing by, let's say, even 2 to 3 degrees centigrade or 4 degrees Fahrenheit, the energy output given by the sun is more than sufficient to explain those numbers.
Can you explain something too? I'm sorry, don't mean to interrupt you, but can you explain when you said a few minutes ago that the sun is like an imperfect light bulb? I would think the average person would think it's a really great light bulb. Why did you say it's an imperfect light bulb? That's an interesting comment.
It's imperfect in the sense that people expect this sun to be that smooth sphere, right? I mean, the whole concept of everything being a smooth and perfect sphere with no features or whatsoever. In fact, we even know that the sun, because of the magnetic field, that is able to espouse huge amount of gas actually that is being out from the sun that actually could affect the telecommunication or the GPS or the cell phone that we are using.
The gas that the sun spews, is that what people refer to called flares?
Those are called flares, and sometimes it's also called coronal mass ejection. That is close to 100 billion cars if you measure in terms of the amount of material that actually came out at one shot in a matter of minutes and hours that this stuff could spew out from the sun, and then eventually, of course, it reaches the Earth's upper atmosphere where it interrupted most of the functioning of how the magnetic field and airflow current at the top of our atmosphere. This is why the impact of the sun on our Earth system is extremely obvious in many, many ways. And it is somewhat, of course, surprising then when it comes to the discussion of the Earth climate system, is that somehow we know all that, and that all of a sudden when people started to discuss about the carbon dioxide emission from the use of natural gas, coal, and oil that we do for our daily life, and all of a sudden people say that the forces of the sun would no longer be important. And then it is indeed that they say only the carbon dioxide emission from the man use of this fossil fuel would be the most important, which is very puzzling for, as a scientist, of course, to think about this.
Well, don't you think that there's a part of humanity, a genuine, good side of humanity, that most people of every tradition, of every walk of life, of every profession, really want to have the environment be clean, and they don't necessarily associate that which they can't control with what's happening to the planet. In other words, it's easier to focus on what we can do to help, clean the air and clean the waters. Like I had read online that there's some type of, not to change the subject, but I had read that the oceans are becoming so acidic that a lot of the fish and marine life are getting killed. And nobody's explained to me, if the oceans are becoming acidic, why are they becoming acidic and what causes that? Well, some people say, well, it has something to do with CO2 or carbon. I don't know if you want to respond to that. Or...
Yes, I do, because
Okay.
I have indeed, myself and David Legates have done a lot of thinking into this question. The whole story there is indeed, I would say, half-truth that you're hearing. There is no doubt that if we humans emit this carbon dioxide, some of it will stay in the atmosphere, of course, but we know also quite a lot of it actually will go into the ocean. And then once it goes into the ocean, of course, because this carbon dioxide will change the natural cycling of what they call the carbonate and the bicarbonate cycles in the biogeochemical changes in the ocean, that you will change the pH of the ocean, which is a measure of the acidity of the ocean.
Correct.
And there is no doubt that when you do that, you will actually make the ocean more acidic. There is also no doubt about that.
The
question then is that what does it do to the system?
But wait, before we get to the question of what it does to the system, I have one other question for you regarding the ocean and the acidity of the ocean, because could it also be true that the hundreds and thousands of underwater volcanoes, because volcanism impacts climate too, could they acidify the ocean?
Oh, sure thing, of course. I mean, this is why actually if you talk about, as we all know that basically 50% of the volume of the ocean is below 2,000 to 3,000 meters, right? So we have only very little amount of water actually at the surface, and the bottom part is no doubt highly complex, but we also know as a fact that those bottom waters are extremely acidic, by the way. So this is why not many shell life could be sustained there if the water is extremely deep. And this is why it's a puzzle. The question, again, let's go back to the question of when you changes the acidity of the ocean, what will the ocean respond? How does it respond? The typical way in which I would say the alarmist or the scary story coming out from even scientists themselves was to say that, well, this is going to kill all the marine life. Essentially, the idea is that then you make the ocean more acidic, then the calcium carbonate would not be able to form. So that calcium carbonate we know is the material that is essentially chalk, right? That's making up the shells, bodies, and everything, right? And if you don't have that, of course, the marine life will be harmed. But I guess the surprising fact has been learned actually as recent as only result that came out last year or so, is that instead of making the shell thinner and weak and, of course, total destruction, the shell actually would grow better. This is a total shocking result that just came out actually about a year or so. And the reason why that you have such a strong contradictory result is because in the old experiment that we have heard of, all this old experiment that's been talking about, how if you change the acidity of the ocean, you will make the shell form less, is because instead of doing the proper experiment, by letting the carbon dioxide in the air and then bubble through the whole system, those people have cheated in their experiment. They have essentially just add weak hydrochloric acid to the water directly itself to study the response of the marine system, which is really a shock, a total shock actually. And in fact, the authors that produced this paper are are immediately being, treated as somebody that is extremely bad by even coming out with such a brilliant, I think, scientific results that, of course, that can be repeated by anyone who's studying them carefully. And the whole idea there is, of course, that don't forget that CO2 is also what I call food for marine life. Okay, we know that CO2 is food for plant life. There's no doubt about that. But CO2 is also food for marine life. There's no doubt about it, because the plants are essentially, because of the ocean, because of the buffer, the layers, the processes, the biogeochemical cycling in the ocean that actually sort of prevented them from taking in more of this carbon. They really, really love carbon. They are actually starving from not having enough carbon. And this is why this contradictory result could come out in so late in the game, because imagine everybody is rushing now in December to try to go to this city called Copenhagen to try to sign the treaty to control the carbon dioxide emission from every industrial use of the all the good stuff that we use, right, the fossil fuel. And then all of a sudden you have such a result that shows such a directly opposite results, and it's very, very scary actually to think about how actually science is actually being being treated as a secondary subject instead of the primary subject that should inform all these public policies and all these governments and all these lawmakers. Well, they're not getting the right information. That's the point.
Could you stand by for one moment? We actually have David Legates on from the University of Delaware, who's a climatologist with a specialty in climatology related to water. But there's a way that you say it, David. Tell us about yourself.
Thank you for inviting me. I'm a hydroclimatologist, and so I'm really interested in the water cycle, particularly how it relates to evaporation and precipitation, and how essentially changing environments change water distributions, particularly on the planet.
We will come back to you, Willie. We have not left the subject. The question then is, what is this thing about rising sea levels? Are the sea levels rising? What does that have to do with? There's all these elements on the wheel of the subject. What is this about rising sea levels, and where does it come from?
Well, sea level rise occurs from a number of processes. I mean, historically, if we look at it, sea level was very low at the end of the last ice age and has since increased as the ice has melted. Now, sea level rises for two reasons. One is the thermal expansion of seawater. That is, as seawater warms, it expands. And so with a warmer climate, as we've had over the last 12 to 20,000 years, the sea level that we've had has expanded in size and therefore has risen that direct dimension. And the second part of it is with the melting of various ice. So as we had a lot of ice stored on the surface in glaciers and in ice caps and things like that, we stored a lot of water that way, which was out of the oceans. Now with the melt that took place with the end of the last glacial period, all that water winds up in the oceans, and so we've seen a long-term rise in sea level. Now, that rise in sea level has been continuing, as I said, for about 20,000 years or so due to the end of the last ice age. So we've seen rising sea levels take place as a direct result of a warmer climate that isn't necessarily a warmer climate due to human actions.
I have a question related to that. In my last interview with Bob Felix, he said that, and it was verified, that glaciers are actually growing, that the very opposite of what we're being told is true, that they're growing. So if there's many, many more thousands of glaciers, mammoth glaciers that are growing, could that contribute to the sea rising in some way, or no?
Well, no. Essentially, there are glaciers that are growing. There are glaciers that are depleting. The glacier dynamics is really complicated. It's not just simply one of temperature rises, therefore snow melts and ice melts, and hence you get runoff into the oceans. Glacial dynamics is really a combination of factors between changes in temperature and changes in precipitation. In a sense, you can get a depleting snowpack simply because temperature remains constant, but the actual snowfall decreases. That's exactly what's happening in Mount Kilimanjaro. There's been a lot of airplay on the fact that the snows of Kilimanjaro are disappearing, and when you actually look at the temperatures of the peak of Mount Kilimanjaro, you see there's virtually no change in temperature whatsoever at that location. What's really happening is we've seen a shift from what was once a wetter climate that produced more snowfall to now a drier climate in that region, which actually produces less snowfall. The glacier dynamics are a lot more complicated, and as a result, sea level dynamics are a lot more complicated than just simply saying temperature rises, therefore glaciers disappear and sea levels rise.
Got you. It's a much more complex system. So where does CO2 and carbon get to be the main focus of the whole dynamic and the basis for new international law?
You know, Kim, can I jump in here?
Please.
This is Willie Soon.
Yes.
I think we should just get back to at least the basic questions that we find it surprising in terms of the level of scientific understandings in our world. It is somewhat surprising, actually. I didn't even dare to ask this kind of question maybe 10 years ago, but I do ask that very frequently these days during my talks and all these places. I started to ask people, how many people know that how many % do we have carbon dioxide in the air today?
That's a great question.
Yes. Do you care to answer that?
I certainly wouldn't know, even though my last name is Greenhouse. Don't assume that I know.
I see. So maybe we'll just cut to the chase by giving the answer away. Well, essentially that it was very surprising. Even some very, very smart people will answer something like, hey, about a few %, things like that. But of course, that's completely wrong. We know that because the number is actually 0.039 or 4%, 0.04%. That really means 4 cents out of your $100. And indeed, think about it that way. This is the reason why it's surprising is that it shows that how we are being brainwashed in a lot of ways by the media, including even the scientific organization, for example, who do not really care to explain to people what some of these basic facts are. And it's very, very surprising. Of course, the bottom line is that they say, because we're going to change, let's say, 100 parts per million, they try to make the number looks large, right? But that's equivalent to, again, 0.01% of the atmosphere, which really is very minute, isn't it? And then they started to say, well, these will cause all the disastrous effects, right? And we can talk about polar bear in a minute. We can talk about the ice. We can talk about for example, basically species extinction, for example. And they started to go down the road of all the disastrous effects. And then at the same time, it's very surprising when people try to point out, yes, hey, we know that the Earth climate system is basically been undergoing this thing of natural cycling in the sense that you have these periods of warming and cooling, right, all the time. And all of a sudden, when man comes along, we emit this carbon dioxide. Again, remember, the amount is extremely small in terms of the volume measured in the atmosphere. And how come this will totally control and take over, essentially, the whole climate system, such that whatever that anything else do, even how the ocean current can move, let's say, the heat from Antarctica to North Atlantic, for example, that would not matter. That's a very surprising. Worse yet, they will say that no matter what the sun does, it also doesn't matter because its CO2 is going to be that important. Okay? To put it in a simpler sense, if you ask yourself then, how much then the power that can be given by this carbon dioxide versus, let's say, the power that could be given by the sun? It's basically the sun is at least 10 times stronger in a sense, right? And then there is no doubt then, in my opinion, if you were to, any changes in the sun would dramatically have a very, very strong control on what the system will do.
Can you explain something, speaking of the sun?
Yes.
I was speaking with an astrophysicist a couple of months ago, and he said that we're in solar cycle 23 and about to go to 24, and that astrophysicists haven't seen this kind of inactivity in the sun in a long time, and it's alarming. What does that mean?
That is simply just referring to how we think that the sun, as we all discussed earlier, that the sun's surface are usually speckled with all these dark spots, magnetic sunspot, right?
Right.
And we are in a sunspot minimum right now, that's true. But then the amount of number of spotless day that we observe, let's say since 2008 until now, is extremely low. It's extremely extended time in the sense that we haven't had a time like this that we have that many days of spotless day. And indeed, this is already breaking the 100 years record for sure. And then, of course, when it comes to weak sunspot activities, one, of course, would like to suggest that because of less energy output coming out from the sun, that perhaps the Earth system would go towards the cooling tendency. And that is indeed, we know that, let's say, a period known as the Little Ice Age, that happened from about 1300 AD to about 1900 AD or so, where we know that the glaciers were growing and things were so cold and perhaps situations were getting drier and drier. So all the water was started to store in this glacial mass and ice sheets and so on and so forth, that those periods are extremely cold. And guess what happened then to the sun's magnetic activity? And we do know for a fact that for a period of time in mid to late 17th century, from about 1645 to 1715 or so, this period is known as the solar Maunder minimum. In fact, I was so curious about this particular period that I wrote a semi-popular book on this to try to explain this phenomenon of the solar Maunder minimum.
What's the name of your book?
It's called the Maunder minimum.
And would the average person be able to understand it, or does it start at an astrophysicist level or climatologist level?
I would only label it as a semi-popular book in the sense that I wrote it. I attempt my best to write it in the layman sense, but then I also try to achieve the hallmark of being a very, very original manuscript, which means the world has not done this sort of research before. So I don't know which way to say about this, but of course, if anybody wants to read on it, please do. And I do believe, of course, it contains a lot of very, very original materials that has never been said before. But the whole purpose was indeed to find out what is this phenomenon of solar Maunder minimum is about. It is indeed about a period of very weak magnetic field on the sun. It is indeed a period of the time from 1645 to 1715 or so that the sun barely have only a few sunspots.
Is that
which
like
is very,
now?
very unusual. Remember, a 70 years period that you don't have that much of a sunspot, which is highly unusual. In fact, on the northern hemisphere of the sun, there were only 2 sunspots that has been known. And those are observed by people from the Paris Observatory. When they saw those, they were so excited, they're beginning to write papers on it. It's just a fairly interesting phenomenon in all by itself. That, hey, we got 2 sunspots, better write a scientific paper on this. And that was so excited at that time. But anyway, so that period was really is a period that is distinguished by its lack of sunspot, of course, appearing on the sun. But then, since then, in the modern age, space age that we're in now, we have also been able to confirm, of course, this Maunder minimum phenomenon by using completely different independent measurements. This can be done by basically measuring the radioisotope of carbon-14 in 3 rings, or measuring another one called the beryllium-10 isotope in ice core, that one can find that indeed such a period, during period of solar Maunder minimum, there was a lot more production of the carbon-14 and the beryllium-10 isotope in the Earth's atmosphere. You can produce a lot of that because the sun's magnetic wind is very, very weak at that time, so we are a lot less shielded away from basically the incoming galactic cosmic ray that can produce such isotope. So this is, of course, that very interesting inverse relationship between the magnetic wind of the sun versus the isotope production on the planet Earth.
Willie, I have a quick question here. So people who measure ice cores can tell what's happening with the sun?
Yes.
We're not dependent on NASA for this.
Yes, indeed, there are plenty of research funded by the European Science Foundation or National Science Foundation of our U.S. National Science Foundation, and even, I would say, private donation of people who funded my work, for example. We all have been working very hard to try to learn about the history of the sun itself. And this is basically, of course, in a goal to just studying the sun for sun's sake. We don't have to try to claim that it's ever so important for climate. But then I think the indirect benefit of that kind of in-depth study would be very beneficial towards gaining more understanding about how the climate system itself changes or not changes, for example. So we do have that sort of coincidence or that kind of confirmation that during solar Maunder minimum period, 1645 to 1715, in northern Europe it's extremely cold. We know that. And we have, frozen lake, and frozen rivers and Thames and the Dutch ice skating phenomenon, so on and so forth. Those are all really fits very, very well in terms of the magnetic history or the sun's light history or in respect to our Earth history itself. And the point is that we can not only confirm such a thing for the 17th century, we know also in a previous time there were many more weak solar magnetic activity periods, actually. In fact, for the last 10,000 years, we have information like we may have seen a lot of this, what we call the Maunder minimum-like sort of activities, many times over, put it that way.
Okay, so hold 1 second here. I just want to chime in. Could it be said that we shouldn't narrow our focus if we want to understand climate? We actually have to expand the focus to include the sun, the magnetic field of the sun, and the stars, and in the context of climate, and that to not do that is actually a disservice to science. Is that correct?
Yes, I would really, with no doubt, support that statement. I'm sure David Legates would support that too, because this is what we call a basic research. Let's just not talk about the sun and the earth. Let's talk about the whole solar system. As we know that the coming and going of the ice ages, these are the stuff that we've been talking about, ice ages that come every 100,000 years or so for the past 2 million years, for example. And what causes that? In fact, the best possible explanation of that is explained by how planet Jupiter and Saturn, which are very heavy planets, how they perturb and changes our relative orbits of the Earth with respect to the sun. Like, for example, how much the tail axis of our Earth is actually going up or down, or how actually the orbits itself relative to the sun precesses, okay? And then how circular or non-circular the orbit is. And those are all caused by Jupiter and Saturn and a bit of Venus. So clearly shows you that you really need to understand the whole system in order to really try to figure out what is happening on the Earth itself. I mean, remember that to explain the ice ages, these are the only truly viable explanation for this ice ages explanation, because there is no other way in which that we can explain why we have this huge amount of mass of ice, actually. As we all know that actually in New York or Boston itself, 21,000 years ago, you got basically a mile or 2 miles thick of ice actually laying over us. And then today, of course, we can live here. Let's go back, don't even have to talk about that long, right? 1,000 years ago, the Vikings were living in the Greenland, where they couldn't be living then right now, because there was just so much ice now, compared to, let's say, 1,000 years ago, where the Vikings was able to colonize southwestern and southeastern part of Greenland, right? Mm-hmm. And basic research are extremely important, of course, because most of these factors are sort of connected, and we need to understand each of these components very carefully, instead of just jumping to the conclusion that, well, for the rest of the future, if we don't cut the carbon dioxide emission, the whole planet is going to be ruined completely. That's just a very strange, non-scientific sort of argument.
David Legates, do you have anything you'd like to add to this?
No, I think Willie's making the argument very well. The argument is really that if we think that the climate system is driven solely by carbon dioxide, and that's the only driver of climate change, you really just don't understand how the climate operates. The climate system is really, really complex. We have spent a lot of money over the last 20 or 30 years to try to understand it, and what we realize is it's almost like the scales on an onion. You start to peel back, and just about the time you think you understand what's happening, then there are other systems involved that have feedback mechanisms that we never thought of, that really make the system a very delicate and intricate climate system. And so it's not just something where you can say, well, increased carbon dioxide, temperature goes up, storms will increase, and therefore that's the future of the world. It's really a really complicated thing, of which carbon dioxide is really a small player. A lot of people get caught up in the fact that we're changing carbon dioxide and that's a radiatively active gas, but the most important greenhouse gas is not carbon dioxide, it's water vapor. It exists in the atmosphere in much higher concentrations of carbon dioxide. It has a much faster overturning ratio, and when it precipitates out in the form of rainfall, it can be very important to human life. If we don't get rain for a long time period, or if you get too much in too short a time, then serious problems happen. And so that's one of the things that I think we really need to focus on, is not just simply carbon dioxide and temperature, but really how are the things that economically and politically and philosophically affect humans and life. It's not really mean global temperature. I mean, to steal a line from Tip O'Neill, all climate is local. The idea is mean global temperature affects nothing directly. Really what we want to know is how is the climate changing where people live. That leads into sea level rise discussions. That leads into discussions of floods and droughts, heat waves, and cold spells. That's more important of a discussion on how those things are changing than really how carbon dioxide is changing, because that's really the important component of the climate system that hits home to various individuals, not just simply what is the carbon concentration of the atmosphere and how does that relate to mean global temperature.
What affects the water vapor then, since it's also a very important thing to be looking at?
Well, it affects temperature as well, but it's not just the temperature of the globe, it's the instability of temperature. I mean, if you have a warmer surface and a colder atmosphere, you get a lot more vertical motion. We see that in summer afternoons where you get thunder showers, where a lot of water is evaporated to the surface, it gets moved aloft. You get condensation, you get precipitation, you get thunderstorms quite a bit. We get tropical storms and hurricanes, for example, in the Gulf of Mexico and other places around the globe that are driven by temperature gradients, by essentially things that are related to the differences between the fact that we have cold poles and a warm equator. And that global circulation starts the atmosphere in motion, and we get local perturbations and local fluctuations on that become increasingly.
What do you think the concept of the Earth's magnetic field? I interviewed Dr. Dean Bonley from Canada, who said that every 100 years we're losing 5% of our magnetic field here, and it has an effect on a lot of things. I'm just wondering, in both of your respective areas of focus, do you think that the loss of Earth's magnetic field is impacting what we're experiencing with climate change in general?
I guess I'll just speak a little bit on this, if possible. This is really soon. I sort of do not like the phrase loss of magnetic field. It's basically just the magnetic field weaken, perhaps, and this is, of course, is related to what we think is generating the magnetic field on Earth itself. Is essentially related to this rotation and convection in the Earth core itself, which we know that the Earth core is essentially liquid iron that is actually flowing, right, in the inner maybe 2,000-3,000 kilometers. And these are just, I would say, a natural cycle of the system. And as to how that connected to the Earth and weather and climate system, I think it's a lot more speculation than we know. I mean, this is where the problem of true science are to be able to add to. And unfortunately, a lot of this speculation will not be very, very prudent in the sense of trying to gain further understanding. I mean, we do know, of course, there is this interesting, there's clear relationship between, the magnetic field of the Earth interacting with basically the wind that is coming out, the charged particle that is coming out from the sun. There's no doubt about that. We have that relationship that at least we can use that to try to understand the phenomenon of aurora, for example. And then short of that, we also do know that if the relationship should changes, one could affect very much the region of the upper air called the stratosphere, which is around 10 to 50 kilometers or so up there, where, it's the whole region there is extremely, I guess, would function mostly through chemical reactions, where most of our ozone reside. 90% of the world ozone reside in the stratosphere, 10% of it in the troposphere. So should those relationship changes, meaning the magnetic field of the Earth and the sun's solar wind changes the relationship, then of course we would have a chance of changing or modulating how the stratosphere changes itself. And then there are, of course, further works that need a lot more detail, of course, that been able to show that how the changes in the stratosphere could actually affect the weather and climate system on the Earth's surface itself. Essentially by changing, of course, what Dave was talking about this, what they call the overturning circulation of the atmosphere air itself, meaning that heat and warm air being transported up from the equator and then moving polewards, right? And by different mechanism, different processes, that those phenomena all should be studied. This is why it's extremely surprising when people were saying that, well, even if you can change the stratosphere, which of course is true. It has only 10% of the Earth's mass and 10% of the Earth's atmosphere mass, and then 90% of it is sitting in the troposphere. Then, hey, you cannot imagine this tiny little 10% could actually push the system at the bottom, which is 90% of it. But unfortunately, I think there are evidence to be able to show that, yes, you can do that. Essentially, it shows that this upper 10% is actually be able to control how much the energy would be able to shed, its energy, the troposphere, will be able to give off its energy to space, essentially. So this little lid there can be also very, very important in terms of controlling the weather and climate system on the Earth's surface and the ocean surface.
I hear that there is more radiation penetrating Earth's atmosphere from space than ever before. Is that correct?
Sorry?
I have heard and read that we are seeing a higher degree of radiation coming in from outer space through our atmosphere than ever before.
It's very hard to define that because it depends on which layers, all right? There is no doubt that the sun's magnetic activity has been quite high, let's say in the 1980s and 90s, and then we're kind of slowly weakening now. And of course, there's speculation that we could go into another Maunder minimum, but then again, that's pure speculation, and I do not like speculation unless you have very, very firm scientific basis. I would say that in general is true and not true, so it depends on where you are, of course. Maybe Dave would add in on that.
No, I haven't really heard of it. I mean, it does make sense that I don't know what time scale we're talking about.
What I'm getting to is that there appears to be a very high incidence of skin cancer.
A lot of that is due more to changing social mores than to solar radiation. I mean, skin cancer has gone up largely because a lot of people spent more time outdoors, had a lot more free time, and in particular, we cover up less now than we did in the past. And so I think in a lot of those cases, there's more people, hence the small probabilities of occurrences result in more people getting skin cancer. I think a lot of that has to do with increase in free time and maybe less clothing, if you will, than anything to do with changing concentrations. I mean, the argument was made back when we were concerned over the ozone depletion. And essentially the ozone hole was really happening over the South Polar region. And the reason for that is you had a circumpolar vortex set up that essentially didn't allow you to bring in ozone, and you had depletion of ozone because ozone is very much a renewable resource. If we don't have oxygen or we don't have solar radiation, then you don't have ozone, but then again, you don't need it. The fact that we have oxygen in the atmosphere and solar radiation coming in would replenish the ozone. And so it was coupled with that people tried to read, well, depleting ozone must therefore lead to increasing skin cancers. And I think that was a bad correlation because a lot of it was shown not to be related to ozone where people live. Over North America, the ozone layer had not changed dramatically, and yet we have seen a lot of increase in skin cancer over the area. So clearly it couldn't be due to changing solar radiation, and it's really due to changing behavior.
What is the role of the ionosphere? How important is the ionosphere?
Kim, I'd like to take just one little step back. Please allow me a few minutes because I think it will be important. This is what, just to amplify on the point where Dave was trying to say about ozone. Since you were going into this increasing incidence of radiations, and then probably it's related to changing transparency, like less ozone, for example, so that you have more ultraviolet radiation of the sun coming in. This is a question, indeed, you come back to the question of what can an astrophysicist add to this sort of study of the Earth itself? I mean, think about this particular question that I'm going to ask. As we know that the world ozone, 90% of them reside in the stratosphere, then 10% in the troposphere. And we know that ozone in the stratosphere, people say, is good because it's blocking out the ultraviolet radiation. And then in the troposphere or near surface, it's not good because ozone is bad for our lungs. But I say, well, let's forget all about it. Let's take all of it out from the atmosphere. This is actually a thought experiment in the sense of Einstein always says that we can do certain thought experiment if we can answer them, of course. It's not good to ask a question when you cannot answer them. One that we can answer is this one.
Okay.
What if we take all of them out? And then we ask ourselves, how long would it take if it come back at all, for it to come back, the ozone? Do you want to make a guess on that?
I'm not even equipped to ask the question, let alone to ponder the answer. I don't know enough, but
I think the answer would be very, very interesting because most people would imagine, because this is where I think it's a tragedy in a lot of sense that the idea that when people were proposing that CFC could break this ozone and could really delete the ozone, that is all nice and true. But what they're forgetting to do is basically ask this question that I just posed. In fact, they even given Nobel Prize of Chemistry, right, 1995, to this 3-person who have actually studied this relationship of CFC, essentially the chlorine that get released that would be able to cause the breakdown of the ozone, right? But they forgot to ask this basic question that I just asked. How long would it take if we take all the ozone away from the Earth's atmosphere? And how long would it take for it to come back, if it come back at all?
Now I really want to know.
Is it 1,000,000 years? Is it 100,000 years? Is it 10,000 years? Is it even 1,000 years? Is it even 100 years? Is it even 10 years? Is it even 1 year?
What is it?
The answer is less than 1 year. It's roughly 150 days. The answer is very not surprising, by the way. This is where I guess as astrophysicists could help here, because what they forgot to tell you is basically, you see, when they speak about the ozone issue, the ozone destruction issue, they are so good at tailoring and narrowing your mind into how we can only damage the ozone, and they never talk about how the ozone could be made, which Dave was trying to tell you. Ozone is a renewable resources.
That was pretty amazing.
Yes. No, the point is, you see, then imagine that people were saying the success of the Montreal Protocol. This is the protocol in 1987 where all the world government who were so convinced that because of the ozone hole is upon us, that if we don't do something about it, we're going to kill every single soul in this planet Earth. And then they forgot to tell you, my point is that you can try all you want, you're not able to destroy all the ozone, because ozone could be made back very quickly. And the secret is nothing more than oxygen, O2, and the sun, the ultraviolet radiation of the sun that would first break down this O2 molecule first into O, so that the extra O could be combined with another O2 that didn't get breakdown.
Okay? So could we say that ozone itself is intelligent?
I'm sorry, I guess I still speak of this as an inorganic process.
When you say it's renewable, meaning it could be created again.
Correct. I mean, the whole point is not to try to make it in the sense that, we are only going to destroy this thing, but then they forgot to tell you the chemical balance that you could make ozone easily and make it fast. That's the whole point. And then this is why I would say that, yes, CFC is maybe not a good thing, but then it doesn't make the issue ever so urgent. And this is why I would think that if people know about this, they will be a whole lot more skeptical about this DuPont and all this other chemical company who's basically essentially want to monopolize on the replacement that they are able to come up with. So it's unfortunate, sort of, I would say, a corruption of all these strange forces, these business forces, this for-profit reasoning to try to basically corrupt science itself, where science are not allowed to prevail and speak, to even give out such a facts, because people do not want to ask the right question. And this gives a same parallel that I'm somehow trying to get across the point very clearly, although we didn't have a chance yet, about what we think about the carbon dioxide role in the atmosphere. I mean, so far as we may have heard, I guess, 1 billion times over by now, that if we don't do something about this carbon dioxide emission, we're going to destroy almost everything on planet Earth. In fact, it's even worse than Hitlerism. I even heard this news like that this morning. And this is really preposterous. I mean, there is no even close basis to try to even come close to suggesting that CO2 is such a bad thing. We haven't even been able to show this. In fact, I have given 20 years of benefit of doubt on this issue about CO2 being able to do all this bad thing to the Earth system. I mean, me, myself, and David Legge has been working extremely hard on such a topic to make sure that we don't misspoke or misspeak about the truth of the facts. And we've been learning, and as far as we can tell, I mean, we've just been not be able to find this impact of this carbon dioxide on the system that is so important according to them. So this I guess, is what the point I'm trying to mention. And then let me just quickly come back to ionosphere. Ionosphere is a very interesting region, yes? I mean, it's clearly a region that is very, very important for propagation of a radio wave and what have you, right? That all these waves that we can send out and then get reflected back, right? So that we can hear it again at the different region of the Earth. I mean, it's clearly a very dynamic region too. And I would say that region, if you were to study how the sun affects on the system, I mean, no doubt that is purely totally dependent on what the sun is actually doing, whether it's spewing out more charged particle this way. Sometimes even when the sun is shooting out some particle, it's not hitting us, it's going elsewhere because the space is extremely big. So in the occasional time in which that, you know, some of this ejection of the particles and the mass coming out from the sun would be able to hit the Earth's ionosphere, oh, no doubt about it. Most of our effects will be interrupted. I mean, there were, for example, in 1989, there was this major event of the sun's spewing out a whole bunch of this gas that actually was able to actually fry some of the transformer, the electrical transformer in places like Montreal, that where, you know, you have blackout for hours, you know, you things like that, event like that. So there is no doubt that there is such a strong essential control of the sun's, whatever it does, it's going to be very, very important, and therefore we should do quite a lot more, in my sense, to try to study a lot more about what the sun can do. Therefore, we will gain a sense of preparedness in the sense of how to anticipate some of this potential disruption in terms of social life, how we function actually on planet Earth.
I understand that the grid, when people refer to the grid, they're talking about the energy grid. Is that what they're talking about?
Correct. Electrical grid, right?
Yes.
I mean, it's basically built it in the sense that so that, you know, in one part of it got shut down, you can close off the other so that you can still function. This is why this sort of system is built by electrical engineers long ago, to make sure that you have a somewhat safety-proof system where you know, one part break down, you will not affect others. But sometimes now we are so interconnected and we don't have a lot of this extra preparedness that we're going to cost us a lot more if we don't get prepared on it, rather than wasting time worried about CO2, for example.
What would you recommend, you and David, in terms of getting prepared for sudden changes? And do you sense there may be sudden changes or changes that are difficult for us?
I've been advocating, for example, more diligent monitoring of the sun itself. I've been advocating a lot more public education, of course. And then, you know, for example, if there were to be complaint about, if we have one of these transformer fry and we don't have enough supply of it, well, I say go ahead, hurry up, and then prepare and invest more in terms of extra transformer.
What does a transformer do? Fill us all in.
Well, it's essentially to try to be able to... Well, Dave, maybe you speak on this, Dave.
I'm not an electrician, but my understanding of an electrical transformer is that essentially it steps down power from the electricity that's being transmitted in the electrical current in the wires to what you could therefore use in your business or in your house. And those transformers would be affected by major emissions from the sun in high energy wavelengths.
Right, they mentioned that it's too expensive, but then, you know, it's in the business sense, if you have a disruption, it costs even more. So whatever it is, you know that we'll pay for it, so just be prepared and get more of this transformer. That's
the take-home message, is just be prepared, particularly with climate. I mean, we keep getting the argument of tipping points and somehow runaway climate scenarios, right, and, you know, that things like that. I mean, we have always seen hurricanes, we've always seen floods and droughts, tornadoes, you know, we've seen
earthquakes.
In the past. Earthquakes, well, we've seen these climate changes that have always happened, and we're always going to see them. So the idea is, if you're living along the coast, you've got to be aware that at some point there's going to be a hurricane or a hurricane remnant that's going to come up and create high winds, high waves, high surf. If you're in the Midwest, that there's going to be severe storms that potentially can produce damaging winds, hail, potentially tornadoes. I mean, these things have happened. They're going to continue to happen. The issue we really need to deal with is making certain that people are able to deal with these kind of events. I mean, small changes that we're talking about in climate change sort of somehow transcends the idea of common sense in some senses, that we become more concerned about a future climate that's more deadly than a climate now that has some things in it that we really need to be paying attention to. So I think there are still lots of things we need to pay attention to in our environment. And certainly I think you started off by saying, you know, we need to be good stewards of the environment. We want to be good stewards of the environment, and certainly do. but we at the same time don't want to be chasing after things that really aren't of the fundamental importance and miss things that in everyday life that really are important. One of the things I'm often asked is, are we seeing more floods? Are we seeing more droughts in northern Delaware? And the answer I have to say is yes, we are. And it has to do with humans. But it has nothing to do with climate change. It has everything to do with more people in the landscape, with more asphalt, with more concrete, with more buildings. The problem is when you've got more people, you've got more demand for water. When you've got more asphalt, when you've got more concrete, when you've got more impervious surfaces, when it rains, that water runs off to the streams much faster. So as a result, we sort of recognize that we've changed the land surface. When we run into situations where we have limited availability of water, that little water doesn't quite go as far as it used to because there's more people demanding it. When we have very heavy rainstorms, as we've had in the past, that water is much more efficiently pushed into the rivers and streams, and that creates more flooding. So we didn't recognize that when we were building back in the 70s and 80s that we had to have retention ponds. Now we recognize the problem, so we're trying to retrofit. So, yeah, we're trying to be good stewards of our environment. There are changes that humans have induced to the climate system and to our local effects. But if we start to believe that the only thing humans do to the environment is carbon dioxide and the only thing we need to fear is climate change, I'm afraid we're going to miss the important things that affect everyday life.
Since we are talking about the context of water and other important things to prepare for, and that climate change is a constant, it's always changing. It's a question of where we're looking. What do you think about desertification?
Well, that's happened in a number of places.
Can you explain desertification?
Sure. Desertification is essentially where you have decreased precipitation and areas, particularly on the margin of deserts, becomes even drier and hence turns into a desert itself. I mean, one of the classic examples of that is the Sahel region of northern Africa. It's on the border of the Sahara Desert. It's an area where rainfall maybe fell 2-3 months out of the year. The people in the area were nomadic herdsmen, so they were moving around, taking their flocks and people around. And one of the things that government does not like are nomads. They don't like people that wander around, particularly when they wander across political borders. So they made them sit still. What happened was they overgrazed the area, they ruined the local vegetation, and as a result, by changing the vegetation, they in fact changed the ability of that wet season to come. It doesn't come for as long, and it doesn't come to be as strong, and as a result, that area has seen a dramatic decrease in precipitation, and that's why we refer to it as desertification. But it's a human modification of the landscape that has in turn affected the climate. It's not a carbon dioxide or a climate change signal that's been driven by SUVs or fossil fuel use or anything like that.
That's an important point. I always wanted to understand that better because a lot of people are psychologically preparing for water wars. We're hearing that there's a huge privatization of water. And conventionally, when we look for water, we're looking into aquifers. And when I interviewed Bill Cox a few years ago about primary water, which is water that comes up through supercooled steam underneath the aquifers, as he talked about water into perpetuity versus only being dependent on aquifers for water, he did say that desertification was causing problems getting waters from aquifers.
Yeah, the problem with increased populations, too, is if you, particularly along the coast, start to overpump the aquifers, you get a lot of saltwater intrusion. And salt essentially destroys the aquifer's ability because then you've got the problem of how do you separate the salt from the water that's coming out of the aquifer, and humans can't drink salt water without becoming dehydrated, so you essentially ruin your aquifers if you overpump them. But we've got, in particularly in the Midwest, we've got a number of aquifer problems where, in a lot of cases, the thought was that the water was endless, and it's not really.
Isn't that what desalinization is about, is taking the salt out of water as a potential water source?
That's usually associated with coastal areas where you've got seawater that has a high salt concentration, and you need to get rid of that. The problem is if you pump an aquifer and it has high salt concentration into it, then you've got an additional expense and problem of how to desalinate the water you're pulling out of the aquifer, and that dramatically decreases the ability of the aquifer to supply water.
Interesting. Okay, so coming back, my last name is Greenhouse, and I'm tired of people talking about how detrimental the greenhouse effect is when I feel like I'm doing a world of good. So I was wondering if you gentlemen could explain to the audiences who are listening to this show, what is the greenhouse effect on a geological level? What does it do? Why are we talking about it? And what is it?
Okay, first of all, the greenhouse effect is largely a misnomer. We say that the greenhouse effect is that the Earth's atmosphere is largely transparent to sunlight and largely opaque or absorbing of heat, so that sunlight gets in, heat doesn't get out. We have known for over 100 years that that's not how a greenhouse works. In fact, the greenhouse works because you don't allow for energy exchange by evaporating water or by moving air, which is two other ways in which you can cool the landscape. I mean, if you come in, for example, on a hot summer afternoon, you will remain hot if you're not allowed to perspire and you're not allowed to turn on a fan to blow cool air across your body. Okay, so that's why a greenhouse works. That having been said, the fact that we have an atmosphere makes the Earth about 30 degrees Celsius warmer than it would be if we didn't have an atmosphere. Therefore, if we didn't have an atmosphere, or if we had an atmosphere that had gases that didn't absorb heat energy, then the Earth would be uninhabitably cold. So a greenhouse effect is really a good phenomenon, and it's why we have life on Earth. However, what we're really talking about when we talk about global warming is an enhanced greenhouse effect. The idea that more carbon dioxide in the atmosphere and other of these energy-absorbing gases, heat-absorbing gases, getting in the atmosphere will increase the temperature above that natural greenhouse effect. And again, one of the things you got to remember is the most important greenhouse gas is not carbon dioxide, it's not methane, it's water vapor. Essentially, 85% of the signal that you see in terms of the warming of the Earth's surface is due to water vapor and not carbon dioxide. And so water vapor is the key ingredient, and it becomes a very complicating factor in climate because, as you're aware, when water vapor condenses, it forms clouds. Clouds, therefore, are a two-edged sword. At night, when you have lots of cloud cover, the temperature remains high because it doesn't allow that energy to escape the space. But in the daytime, lots of cloud cover keeps it cool because they reflect off solar radiation and light from the sun. So clouds are really a wild card in the system because how they actually behave relative to temperature changes, how they might change or respond to various climate changes is not well understood and very difficult to predict. And because it's the most important greenhouse gas, it therefore is the important variable in the Earth's atmosphere and not carbon dioxide.
Stunning. I've never heard this. I've never heard anything about water vapor. I've never heard anything about the greenhouse effect. It's even being referred to, how it's actually helping. I never heard anything about the clouds and that the clouds are the wild card in climate. Very interesting.
See, this is an introductory climate course. If you took any introductory climate course, that's the kind of thing you get. The problem is that's not the take-home message people want you to hear in the media. And what they really want to hear is that the world is becoming a very bad place, and unless you give me all your power to control carbon dioxide emissions, life as we know it is going to cease to exist. And I can tell you that's not the case.
Is there anything else you two would like to discuss that is not being talked about that's very important to you?
I myself cannot think of anything extra except to try to keep emphasizing that it is close to being insane to try to keep insisting that this carbon dioxide changes will actually lead to all this disaster in the future that doomsayers and all these politicians and profiteers are trying to tell us. The fact is that even how the greenhouse effect of the CO2 would work, it's totally and completely tied to how the water and the cloud would do. And indeed, that one cannot separate that also easily according to what they are saying. So this is why it's ever so important to try to emphasize the fundamental aspect of how the greenhouse effect would actually work, rather than in which the cartoon character that they've been trying to create for us to try to indoctrinate school kids on this issue, where they try to say that, well, if you add all this carbon dioxide, you're going to be able to make more rain, you're going to make less rain, you're going to make some places warmer, some places cooler. I mean, it is a very pseudo-scientific proposition to try to suggest to people about, everything is causing everything. I mean, that's just not a very good proposition. And then here they are even worse. They are trying to propose that carbon dioxide will cause just about everything, whereas something else, especially like the sun, would not be able to affect it. This is really very strange. I mean, I would like to end by just saying one more thing about comparing between, let's say, the role of the sun and the role of carbon dioxide in the Earth climate system. Because this topic has been so widely sold to the public that, they keep saying that, well, it's only the CO2 and it's not the sun that can do it. They say, well, they have already proven that the sun could not be affecting the Earth climate system. Since when? I mean, let me now start by giving you a very simple analogy. Imagine that the Earth climate system is this football player from the New England Patriots quarterback by the name of Tom Brady. I hope some of the audience know that. Imagine the Earth climate system is Tom Brady. And they try to suggest that the sun, which I will give you the analogy, which is a big gorilla drinking some just water, okay, because he's on diet. This big gorilla that is actually not 800 pounds, by the way. Typical weight of gorilla is at least 1,000 to 2,000 pounds. So this big gorilla, they say that this big gorilla, because they're drinking water, is not able to push Tom Brady. Whereas they say CO2 is a guy, guess who that is? It will be Willie Soon, of course. I picked Willie Soon because Willie Soon has been very greedy. He's been eating a lot of hamburgers, gaining a lot of weight. This is where they say that, it is the relative difference that is more important. I say no, it's the absolute level that is very important. They say Willie Soon has been eating a lot of hamburgers, gaining a lot of weight. So therefore, he should be able to push this Tom Brady easily. So this is the kind of very fairly accurate analogy in terms of trying to compare the relative strength of basically the Earth system, the CO2, and the sun itself. So the audience should be able to decide who is more powerful, because they say that the sun, the typical way of which they try to dismiss the sun is that they say, well, we know the sun is a gorilla, but he's drinking water, he's on diet. And you, Willie Soon, on the other hand, you're eating a lot of hamburger, you're gaining a lot of weight, so you should be able to push Tom Brady. But ultimately, Tom Brady is still a big guy compared to Willie Soon, by the way. So instead of Willie Soon pushing Tom Brady, it is more of a case of Tom Brady pushing Willie Soon itself. This is why in cases in which we have data, for example, we know that when we emit all this fossil fuel carbon dioxide, not all of that really ended up in the atmosphere. In fact, how much that is remained in the atmosphere is completely controlled by the climate system itself, like how much rainfall you have, meaning how much trees were growing or not tree growing.
Sorry to interrupt you, but I heard just last week that carbon is heavier than air.
Yes, it is, right? I mean, it has CO2. So O2 is O2, but C, there's extra C. But then, so that's true, because N2 is also lighter. That's true.
Sorry, not to have taken you off.
Right.
Put it now in the true metaphoric context between the sun, CO2, and us causing a situation to go out of whack. What you're both really saying is that it's impossible, given the number of variables, for humans to be causing a problem with the atmosphere, with weather, and with climate, because the entire climate system is a astronomical and physics context. It's not just what's here, it's what's happening in space, it's what's happening with the sun. And the sun cannot be taken out of the critical equation because it's an integral part of climate.
I would put it slightly differently. I would just simply say that to try to think of the climate system that is completely predominant in their case, dominated by how much carbon dioxide amount we have in there, I would say it's just crazy, completely wrong in that sense. That is the part that we know, okay? The part that we do not know is exactly what are the key factors that will be important, depend on the timing, of course, the conditioning of the history of the Earth climate system. And at any given time, I would strongly suggest that, we will always have that season. So whatever it does in the season is extremely important, because guess what? No two summers are the same. No two winters are the same. So the way I would think about the Earth system is indeed to think of it freely that way, that is in the most natural way, where the sun is that changing light bulb, the light sources that is constantly changing, even though it changes very little, like he's on diet, drinking water, okay, that gorilla, he still would be able to push Tom Brady up or down, actually. Tom Brady, on the other hand, would not be able to push him, right? Because Tom Brady could do all he wants. He can eat all kinds of hamburger. He still would not be able to reach 2,000 pounds to be able to push back the sun. So that fact we know for sure. And then to try to suggest that the sun would not be at all important because he's drinking water on diet compared to, let's say, Willie Soon, who's eating hamburger, which is that CO2, then I think it's just wrong in the total sense. Whereas, the question is not about unknown. There are a lot of things that we do not understand yet for sure. But there are also a few things that we do understand, which I think we can make that simple conclusion. It is a simple conclusion that, atmospheric carbon dioxide is not the major driver for the Earth climate system. This is why when all the data started to show up, for example, data for the last recent 10 or 15 years or so, where one could not really find a clear impact of the increasing atmospheric carbon dioxide on the Earth, for example, global temperature, for example, one would not be able to find that. They started to make this sort of a revisionist sort of a story by saying, well, we have predicted that it doesn't have to warm the Earth system all the time. You know what? It come a bit too late in terms of scientific hypothesis testing. Those people have been really strongly projecting and been claiming all over the place about how you increase atmospheric CO2, you're bound to make the Earth warmer, and it ought to be able to show up in the global temperature. And now that the global temperature doesn't show that, they started to make this sort of revisionist story. I think with that, I'll just stop and then let Dave go in on this.
Yeah, I think the issue is that, we want to make everything a black or white issue, and the idea is that either humans affect the climate or they have no effect on their environment whatsoever. And I think we can definitely say humans affect our environment in many ways, some good, some very bad. And that's why we try to do things much better on. But with this issue in particular, carbon dioxide is not a pollutant in that sense. It is not harmful to life on Earth, and it is not likely to create major changes in the system and climate system that we really are seeing in the press. One of the things I think that it was classic about, it must have been 10 years ago now, Willie and I were in Congress. We were asked to testify, and Michael Mann was there, and he essentially made the comment that the sun has no influence on climate. And he was stopped by Senator Inhofe, who said, are you saying that the sun has no impact whatsoever? And his answer was, no, of course it has impact on climate, but we just can't control that. And I think that's where it comes all back to, is this whole discussion really isn't a science discussion, it's a controlling discussion. I think there's other ulterior motives as to why you're not hearing the standard climate 101 course material, but instead hearing things that various people want you to hear.
I was sharing on the last segment that I did, segment 1 of Climate and Weather, that I did see Inconvenient Truth. I did read the book. I did see the movie, and I was hypnotized. Really feel that I got hypnotized, A, because I was receptive. I do feel on a completely, this is a whole separate statement, but I do feel that, and it bothers me that we pollute so much. We meaning just humans, industries, the whole bit. That's a separate, connected but separate conversation. But what sold me then was the computer models that were used to tell their story. And then I realized that computer models, it's like garbage in, garbage out, data in, data out. Am I correct?
Gospel in, garbage out.
Yeah. In other words, I didn't realize the extent to which computer models, because for the average person, gentlemen, when we see a computer model happening, we unconsciously receive that as being factual, like true, factual. And therefore, you can do a computer model of something, and you can tell any story you want to tell. And when you're listening to people who say and communicate that they're communicating the science of something, I would bet you 98% of the people or 90% of the people believe it unconsciously. Am I right?
I think so. Yes, indeed. I have to admit that it is very powerful. I mean, it is indeed taken me that long, like I say. After 20 years, I mean, let's say the first 15 years I was very quiet. I was quiet because I want to be sure. Right? I want to be sure because as a scientist, you just cannot talk and then be irresponsible about what you say. So I want to be very, very responsible person, and then I also want to give them the benefit of the doubt, right? In science sense, that is very, very important. But then But of course, I was completely not impressed of the computer modeling, because we know that it's purely guesswork, and in fact it's worse than a computer game, because this is a game in which there's not much of a level of sophistication that they claim they have. I mean, there is no chance that for them to even present pick any type of cloud you want, please. Any type of cloud, name it, okay, that you can read in a standard meteorological textbook. That tell me which one have they represented the cloud in the system correctly. Just pick some part of the world ocean, see which part of it that they have presented it correctly. Pick any land surfaces that you want. Tell me which one have they done it correctly. So it is not even close to resemblance the reality that we have. And the problem with those powerful, here's a few simple points about climate model. Here's the problem that I have with them. Let me summarize it in maybe 1 or 2 points or 3 points. Even when you got it right, you got it for the wrong reason. Let's say that they always say, oh, we can do this well. We can calculate this global temperature. It looks so impressive. We can fit all of this, and it seems to agree with it. But I would say you know for sure you're going in that because looking at your climate model, you didn't put in this, you put in that, you didn't put in that, and yet how come your result is looking the same like the what is measured? That's totally suspicious. Okay? And then most of the time that they do, let's say in terms of try to project the Earth system to the future, I mean, they know outright that they have not included all these other factors like ocean current or even how the sun would do. They have not included all of these key factors that we know that is working right now, and then they just simply chose to say that, well, we're going to turn off this because we're going to study only the CO2 effects, and the future and it's going to be driven by all of that. So this is where that is really fundamentally wrong with the climate models, because they are not even to the level of sophistication of tools that we know that would work properly. This is just not even close. I mean, computer game, you actually can get a sense of joy out of playing those computer games. But this one is just purely a black box that you kind of don't know what it actually does, and is going around in it, and you just spew out something, and okay, that's the truth. I mean, it's just ridiculous to try to think that the climate model could do all this work that people claim that it can do. It just simply cannot be.
Thank you for sharing that. It's extremely hypnotizing. It sold me. I'm sure it sold many people that unconsciously are environmental activists, advocates, people that are very concerned. Good people bought it. I've been on a mission for 25 years, and part of my job is to stay receptive and to ask questions and to ask difficult questions to bring forth new answers and new directions for humanity. But the average person, once you buy in on something, it's very, very difficult to say, you know what, during this period of time, when I heard this, I bought it. But I've looked at facts. I've done an analysis of this. I've spent a lot of time on it. And I realized there's missing pieces, critical missing pieces that aren't even in the center of this focus that makes me retract. And now I'm in a different place.
That's very good. In fact, I do curious about how you really physically change your mind. I mean, I would just reiterate the example. I mean, for example, we know CO2 is a greenhouse gas, right? That one, no one would deny that, right?
Right.
And then we know that greenhouse gas will give this so-called warming effect, yes, because you have more of these changes of the energy budget that you can actually only add heat to the system, right? So, and then when you look at the real world data, and we know, for example, let's go back to the example of last 15 years or so, right? We know that this CO2 is rising, still rising rapidly, okay? It's going up, changes quite a bit, by the way, last 15 years. And when you look at the temperature data, and somehow this temperature data is not only not warming up, it's sort of showing a cooling tendency.
Yep.
Don't you think that you should really take a step back and take a deep breath instead of still be so committed to that blind faith that you actually have put in? I mean, some people are not able to step out of that. I don't know what is it about what we say here that is so offending to them. Some people would just quickly say really soon, well, he's taking money from Exxon Mobil, so on and so forth, that he could not be able to make any clear statement on science or things like that. I mean, I will give an example if we can. Still have time, we can talk about the polar bear example, that I've done research on polar bear. So on the issues indeed that people are saying that, well, you are
wait,
discredited because you are taking money from ExxonMobil to do research. Well, I say, I've also taken money from National Science Foundation. I've also taken money from NASA. I've taken also money from United States Air Force. Does that mean that, which part of it that you think that I say is not true? This is where the issue has become very ad hominem and becoming senseless in a lot of ways. Objectivity is extremely important. Money could never ever buy a person like myself or David Legates, I can assure you. I know him long enough to know that money was never ever a factor. You know, our research has always been what you call curiosity-driven sort of a research that I'm sorry to say that most of it are sort of disappearing ever so gradually or rapidly. It depends on where you look, okay, in the field of studying this climate change. Because, I mean, maybe that Dave didn't emphasize the number. Over the last 15 or 20 years or so, we have spent almost $80 billion or more. In fact, some people estimate the number to be 100 billion or more over the whole globe. Of course, 80 billion belongs to the U.S. number. And we have spent that much of money. And this has become a very, very big money items in terms of all the university overhead money and so on and so forth. Even a free institution like a Harvard or all these places are no longer free because they are so tied to able to get a little bit more prestige, to get that much more of funding, to have this center for study of the earth environment, to be able to protect the earth environment, all in goodwill. But unfortunately, that part of it has becoming very tainted and very corrupted that they are unable to formulate simple questions to try to get at the real truth, which is really very unfortunate. I mean, now I want to speak on an example of some of the research that I've done on polar bear.
Can you hold 1 second about the polar bear?
Sure.
David, is there anything you want to add to that, to what he just said about the institutions and what's happening with regard to science and the funding of science?
I agree with everything he said. It's exactly right on.
All right, let's get to the polar bear. What is this thing about the polar bear on the ice?
Here's a thing that I've been sort of reluctant in the sense of trying to dive myself in terms of the full research, in terms of trying to understand the biology of polar bears, and there are other complexity that actually attracted me, of course, but it's the physical aspect of it, of course, of how ice really works and how the Arctic weather really changes and things like that. And ever since, I think, in 2005 or so, I've been contacted by a biologist, a polar bear biologist from somewhere in Nunavut, I believe. And he contacted me because he was very, very interested in how much information that I can pull in terms of trying to get the condition of the ice and the weather and the temperature, and historically too, of course, not only the current 50 years, for example. Let's say how far back can we go, maybe 1,000 years ago or so on and so forth. And we are focusing on the area called the Hudson Bay, the Western Hudson Bay, where indeed that this is the most well-studied polar bear population in the world. As we know, that polar bear has about 19 subpopulations in different parts of the Arctic, right? And this is one of the southernmost, almost the second southernmost part of the population. Indeed, that has been some sort of prediction or projection to say that if anything were to happen to the polar bear population, this southernmost population would be to feel it first. They will be able to detect it first. So this polar bear biologist contacted me, and his name is Marcus Dyck,
Okay.
D-Y-C-K.
Okay.
And he was a very young biologist who's actually, I would say, even a few biologists who just go there and watch what the polar bear is doing. Actually, he's been hiding under something to look for study the polar bear behaviors. And he has other interests, of course. But here we are only trying to assess the questions about the true danger of the relationship of polar bear with the surrounding, right? And ice, of course, is one of the best connector there. So when I started to pull out all those data with help of also David Legates, we started to pull out all the temperature data, precipitation, rainfall data, and snowfall data, so on and so forth, around Western Hudson Bay. We look and look and look. We just couldn't find anything that is what you call alarming. For example, the whole proposition is that it's because the Earth is warming, so therefore it started to melt the ice earlier and earlier. So the ice started to melt earlier and earlier so that the polar bear could not sit on the ice, and so they had to come ashore earlier and earlier. So during springtime, of course. So this is what the proposition is.
Hold on 1 second. When you say this is what the proposition is, meaning this is what we're being told.
Yes.
Okay, very good.
The alarmists are proposing. They're essentially saying that as you warm, you melt the ice, and then essentially the more connection is that the spring ice are melting earlier and earlier, so that the polar bear has to come ashore earlier, so they get more and more hungry. In fact, the time they be able to spend is less and less on the ice floe, so they can get less access to the seal that they're supposed to eat, right?
Yeah, and by the way, I got sucked into this too. I was very sad. I looked at those pictures of the polar bears. I thought, oh my God. When you're an animal lover and you see something like that, I mean, I'm a sucker for that. I'm sure there's
I'm sorry,
many.
me too.
Yeah.
I couldn't imagine a world without polar bear for sure. I mean, in my opinion. But the fact is that let's just try to find out the facts first. What are the truth about this situation? And then before we jump to the gun by saying that, well, by cutting CO2 emission, are we going to help this polar bear or what?
I agree.
That's what basically they're trying to propose. Unfortunately, again, I think polar bear has been used as that symbolism that they're trying to do. I mean, it's all about their cause, right? It's all about their whole idea instead of actually what the polar bear is actually doing or would that really help the polar bear in the first place. So this is why I started to become very suspicious. So I started to research the issue. I learned so much about the polar bear itself, which I, of course, enjoy doing that. Learning is one of the enjoyment, in my opinion. But then when I dig into this thing very deeply, I really just couldn't find those supporting evidence for those suggestions that you're going to kill this polar bear population because the globe is going to warm. And then I started to think more and more and more. And then I come up with actually my own original hypothesis, just like the question that I've been asking about ozone. The hypothesis that I have is indeed, the question is this. In fact, I come up with a statement first. I truly think that ice is perhaps the ultimate enemy for polar bear. It is a shocking conclusion in that sense. The shocking conclusion is because I started to ponder, what happened to the polar bear population during the last glacial maximum? Let's say the Hudson Bay area was completely ice covered. Where does the polar bear go? How do they survive until today?
That's a great question. I'd like to know.
During the warm time. First of all, thick ice means what? There'll be less biological activity. I mean, most of the oceans are covered with ice. They don't have a drill, so they don't know how to get access to this, drill a hole into the ocean where maybe the lower part of the ocean, Arctic Ocean, will still be warm, or Hudson Bay, where you can get access to the seal. So this is why I come up with the answer that ice is the ultimate enemy. Okay? Here's another extreme. If every single piece of the ice on Arctic melted away and then sustained for, let's say, 50 years or 100 years, then of course, polar bear will go off. That's no doubt about that. That's all right. I agree with that. But the question is, what are the best conditions for polar bear itself? Or even better question to ask is that how many polar bear do you think we can sustain optimally?
Those are great questions.
Right. And I come up with an answer, actually. And I say that extreme ice is very bad, but polar bear really wants a condition in which that you have a lot of food, isn't it?
Yes.
And to have a lot of food, you really need the ocean to be very, very productive. That actually usually associated with less ice condition. And then productive to a point where, of course, not completely melted away, right? So what I conclude is that the weather and climate that we have today is not even close to the optimal condition for the polar bears. I measure that condition relative to, let's say, the medieval warm period, which we know the Vikings could live in Greenland, and they first went to Iceland, we know that, and went to Greenland. That's from about 800 AD to about 1200 AD or so, right? And this is how I measure that, okay? Because at that time, if you study even a bit of the Icelandic history, because they're very good at keeping record, right? You will see quite a few mention, by the way, of how, kids coming from Norway somehow, or Denmark even, come to Iceland and work very hard for years and years and years and save up all the money and then buy a polar bear, somehow go back into the journey and give it as a present to the king of Norway, for example. There's a story like that. There's all kinds of tales like that. This is one of the examples. But guess what happened? This is during the time of medieval warm period. And then during the Little Ice Age, where the Icelandic people are still keeping a lot of good record. In fact, they talk a lot about the sea ice is really encroaching on them, so on and so forth, right? You really barely find even that much of a mention of polar bears around, okay? I mean, that was my hypothesis. But I was just at least trying to tell you that if you think sensibly, absolutely no ice is bad. No one is doubting that. But then too much ice is really bad also for the polar bear itself. And then And then I could even make a further deduction that the current polar ice condition is really not optimal yet even, because possibly that we could support even more ocean activity, ocean biology, so that you can remember, this is talking about all the way from small little planktons all the way up to this bigger animal, through fish, and then ultimately through the seal that they love to eat. And then when my research associate, my friend Marcus Dyke, who's researching on, let's say, sources of food eaten by polar bear, for example, I mean, he was researching on berries and all these other, not their main food, but then it's enough to supply them for certain thing. Oh, they had such a hard time publishing their paper. In fact, one of the group from American Natural History Museum in New York City one time even contacted me about the difficulties of their paper, where they were observing actually some polar bear in Salzburg was actually, instead of attacking the goose, they actually are eating the goose egg, and they actually observed such a wildlife situation, so they recorded it down, trying to print it and publish as a paper, and then try to estimate how much energy you could gain from this, so on and so forth. To me, this is a fine process of doing science. And guess what? Extremely hard time of trying to publish these things. Simply because people are trying to stop this even idea that polar bear could eat any other things except for the seal, where they could create this dependency on ice so solely. This is the ultimate things that make things truly ugly in a lot of ways, where I felt very, very negative on. But then I'm a very outward-looking and positive-looking kind of person. I keep saying that, hopefully this will end. Hopefully we can do a lot more things will change.
So
in fact, I keep doing research to try to further understand and share all of this with them, by the way. I say to them, please tell me what is wrong with the idea by just telling you what I just tell you. Please. Because science is all about being proven wrong, right? And then also therefore a certain conclusion you make would be truly correct, that we can be able to understand it all together, maybe only through that way, through that kind of overstanding. I mean, science, after all, is the word stand for overstanding rather than understanding, that we can really be able to understand what is going on with the polar bear itself. I mean, rather than just simply saying, emit more of this carbon dioxide is going to kill the polar bear. That is clearly not true. And in fact, now let's go back to the basic. You may have heard many times over that people say, we have somewhat of a data, like let's say in the 50s and the 60s, the best estimate, which is not very accurate, of course, of the polar bear in the world is maybe running from about 5,000 to 10,000, okay? And then the current estimate, the number could go from 20,000 to even up to 27 or 28 I've seen, okay? And guess what happened during that period? It clearly has nothing to do with the warming temperature too. All that effects of increased population was mainly due to an agreement that we all signed in about 1970, actually early 70s. The world, Arctic regions or countries agreed to sign to an agreement that we're going to have a lot more limited take of the polar bear in the sense of hunting for it, right? Because traditional life still depends on polar bear actually as food, as clothing, as all kinds of stuff, where you will have a lot more systematic and control, and this is where the management of the polar bear life management beginning to come in, which I think is completely a healthy thing to do. Because after all, we don't want to senselessly kill them, and hunt them down until they could not really have a chance to even survive. I think that it is that kind of commonsensical thing that is actually missing from today's argument, which is a shame in a lot of ways, because after all, as you say, all of us have very, very good will. We all have a very extremely good will in terms of trying to make the world a better place for everyone. No doubt about that. And then how come we could not even communicate such basic discussion? We couldn't even get such a discussion going. In fact, you will see how many times they're trying to stop me from even saying this thing that I'm saying to you. I wrote already 3 papers on this. One of the paper, by the way, we were contracted by the state of Alaska government to write this paper. And immediately, guess what? They managed to say that we are some kind of pet to Sarah Palin, which is obviously not true. I mean, it's not even coming from her. It's just one of the state office that is controlling or studying polar bears population. They do wanted to know whether some of the prediction that is offered by this U.S. Geological Survey is true, because U.S. Geological Survey came out with the report that's saying, by 2050, we know that if we don't do nothing about cutting down CO2 emission, that 2/3 of the world population, 66.7% of the polar bear will die off. That is a remarkable statement to make, by the way. And then my job was simply just to go into the step in which these people are making the projection or the prediction. And then we just check every single step that they do. And then in parts where we don't understand what they did, we ask them questions. They refuse to cooperate, so on and so forth. So we wrote our papers, and then we come up with the conclusion, we don't think this projection is correct because it has not followed all this scientific procedure that we're supposed to follow. And that make myself a public enemy number one. I mean, I'm probably the person who really want to kill the world polar bear according to them, which of course is obviously untrue in that sense. So this is why I keep emphasizing a very simple theme for me. I'm a very simple scientist in a very simple way, uncomplicated way, that I only wanted to learn what the facts are. The rest of it, I'd say that most of these politicians, please, do your best. God bless and do your best. But then please, don't try to misinform and sell people things that is not true. And be very careful. And then the public, of course, also should have a duty themselves to try to learn all this information instead of being fed by the media, especially the mainstream media, who's really incapable of getting at the truth, in my opinion, because they have been biased from day one. I don't know for what reason, I don't know. But all I know is that it's been extremely difficult to try to get the mainstream media to even hear any of this because they just choose not to. It's a very strange phenomenon. I really think that, if they have the stronger truth, please come out and say it.
Willie, in my experience, being on a mission for 25 years, true discovery can only happen when it's funded in such a way that true discovery is free and clear of being co-opted politically and stifled, and the people involved being in bondage. Academia is notorious, I would say, over the last 20 years, of being co-opted by corporate concerns and shackles. And I'm not saying all academia is stuck or co-opted. I'm saying a large part of academia has already been infiltrated and polluted. And that is why I think, as I'm listening to you and doing mostly a lot of listening, as an audience person would do, that you've gone through what you're going through. Because in order to be true to science, you have to be willing to find out the truth, and you have to be empowered to ask the questions that nobody wants to ask because it's tough. It's tough to ask the tough questions, the good questions. It's a pleasure because that's really who you are and what your work's about. But unfortunately, academia has become political, and getting money is political. And even though you've gotten money from a lot of different places, you're still true to your science. But you're in an environment, or you dwell in an environment of inquiry that's very shackled. And therefore, that's why I think a lot of what you've gone through is very, very disempowering for you. But I appreciate your courage in coming out and your willingness to educate the mainstream public, those that are interested. I think one of the saddest things in this subject that I've seen, and I've watched a lot of YouTube videos just to even get a handle on how both the science is going and being spoken about, but also the politics and the legalization of the obstruction of a piece of science. And when former Vice President Gore says that this is really a concluded subject and it's already agreed upon, like it's a done deal, that's very sad to me. And you have to understand, too, that citizens in this country and individuals and people in different parts of the world get very connected to who they feel and perceive their leaders to be. And so many environmental advocates and activists who were glad that he cared about something regarding the environment. And it's easy for a person to lose their way, their ability to discern quickly, when they look to outside leaders, particularly political leaders, to be feeding them the distillation of the truth or purity. And the reality is, unfortunately, that any politician, whether they're in politics or out of politics, formally or informally, the minute something is concluded in the realm of something as complex as climate, with the omission of even the sun's contribution, let alone everything else that you've mentioned, you have an obstruction of science. You have an obstruction of the truth via omission. And omission is the portal to something being obstructed. It's as bad as giving polluted information, not giving verifiable, correct information. And so I feel very sad.
Well, I can add one more observation that I have that I can never ever imagine, actually, as a practicing scientist, to even witness such a thing. I mean, that happens only 2-3 years ago at one of the biggest meeting of the Earth scientists in the American Geophysical Union meeting in San Francisco in December. They invited Mr. Gore to speak. And I cannot tell you how many times he has falsely presented the information. And I can only imagine that when you hear things that is not true, again, I have to tell you that this is not just me knowing it, and I have to say that I would say maybe 80% of the crowd is smart enough to know that. And I keep hearing applause. I'm really totally shocked. You will politely not clap when somebody says something not true. In fact, some of them is close to lies. And then, of course, you oftentimes even hear some of the scientists who, of course, I don't no longer call them scientists because I really put them in quote, scientists. They would even say, well, you know, Mr. Gore has done a service. I've learned something from it. I mean, it's a fairly amazing phenomenon, okay? It's a reverse of the situation. I've learned something from it. It's a fairly amazing phenomenon, okay? It's a reverse of the situation. The world most intelligent, supposed to be intelligent organization on this earth science, study of the earth, that you have all these leaders coming up and talking opposite. You're supposed to tell Mr. Gore what the truth is. In fact, I can assure you he has some of the best information available, a person of that importance. The simple fact of, for example, the graph that he showed in Inconvenient Truth on the level of carbon dioxide and temperature, right, for the ice core record that goes back 650,000 years. The fact that when the data first came out in a shorter form for about 160,000 years in 1987, Mr. Gore was already know about that results. In fact, in 1992, in Earth in Balance, he already put in that result. So we're talking back history of at least, 10, 20 years. Even as of 2007, he's still purposefully misleading people to try to give it not quite of the exact word, and is almost a lawyer writing the text where he say, well, the relationship is very complicated, but of all the fact that is most important, you only have to remember this. When there is more CO2, there's more temperature. Even the order or the arrangement of the word. It's not saying there's more temperature, there's more CO2.
I don't understand what you're saying. I'm
no,
clear.
He was trying to suggest that changes of the CO2 is causing the temperature to change in the ice core data results. But the fact that it's been known for about 22 years now in the ice core community plus today's community is that for that data sets, we know that you could never show that it's the atmospheric carbon dioxide that is causing the temperature to change. In fact, it's the reverse, right? It's always the temperature that is changing first, and then the Earth system responds so that it allows more carbon dioxide into the atmosphere or less carbon dioxide into the atmosphere. It depends on how warm or how cold the temperature is, or how warm or how wet or how dry the Earth system is. Okay? You understand? He's actually switched the causality around. He tried to ask people to try to ignore this cause and effect picture that has been known. And then he tried to quickly go over that, because the reason why he keeps using that graph, I believe, is because graphically it's very impressive.
That's what I was going to say. It's hypnotizing.
Very impressive. And then plus that the last scene where he flew up, of course, saying the CO2 level is so high now, it's even more dramatic, right? I mean, but of all this, all I wanted to say is that he knew all those facts too. He knew about this. When I remember 1 or 2 times he was asked about that, he said, wow, we know all about that. We never say that it's the carbon dioxide that's causing the temperature to change. All we're saying is that the carbon dioxide is just an amplifier to the system, in the sense that when you started to warm, so you bring more carbon dioxide out, then the carbon dioxide sort of help it to make it even warmer. That's a very interesting admission, by the way. He did admit that to that point, but very rarely known. I even go as far as checking and entertaining that idea to see whether it's right or wrong. And I've written a paper in 2007 that is close to 50 pages, which is very long for scientific standard. I'm not so long-winded, by the way. I just write very detailed, very exactly. And I couldn't support that statement too. So, I don't know what else is left in terms of the integrity of the process or the actual understanding of this relationship between CO2 and temperature. And worse yet, a person like the producer of his movie, Laurie David. Do you know that person?
Yes, I know of her.
Yes. She actually, after the success of The Inconvenient Truth, I presume that she also won a trophy for herself. So she actually wrote a book called A Guide to Global Warming, a special guide to global warming. And those book was said to be targeting children 8 years and older, okay? To try to target the school children, and then collaborating with another person by the name of Cumbria Gordon. They were so unlucky or lucky, depends on how you see this. The first day the book came out, I roughly remember, is September 1st, I remember, of 2007. I was at a bookstore with my son, which is about 3 years old at that time. But I, of course, knew that it's coming out, but then I just so happened to be in bookstore that day, and that day it came out, so I saw the book. Okay, I opened it, I looked. I didn't flip more than 16 pages, and I saw one already. It's the same stuff again. It's the same stuff of this carbon dioxide and temperature curve. And of course, in that writing, they were specifically trying to say that CO2 is an air pollutant that is, we human emit. Of course, forgot to say that, 650,000 years ago, there couldn't possibly be a SUV there. And then they was trying to say, well, look at this graph. You just have to do this flip page to see how close the relationship between CO2 and temperature is. With the suggestion, of course, that more CO2 means temperature warming. And if you look carefully in the graph, something totally damaging for them that is happening. I saw that graph, of course. It's actually showing two curves. One is orange curve, one is blue curve. The essential point is that in the label, they say the orange curve, let's say, is the carbon dioxide, and then the blue curve is the temperature. They plot it in such a way that they show that the orange curve actually is changing first, and then the blue curve, the temperature response. Okay? You see what I'm saying?
Yes.
They are actually saying that carbon dioxide is causing all the temperature to changes, okay, over 650,000 years. And then, remember what I just told you, we know this stuff about temperature causing the CO2 to change at least 20 years ago when the result first came out for 160,000 years, and then in 1999 we extended to 420,000 years, and then in 2005 we extended to about 650,000 years. And it turns out that they actually switched the graph, the curve, to try to make the CO2, the actual temperature curve is turned into CO2, and then the actually CO2 curve is turned into temperature. When I saw this, I called my friend, I say, Bob, do you want to pay for this book? Because I could not buy this book, with principal. It's $20, but I refuse to pay it. If you want to do it, I'll write a 2-page report for you. Something very bad in this book, I say. And remember, they're targeting children. So I'm doubly not happy with this because they switched the graph. And then I wrote the report up by showing, of course, that this is completely opposite, they are wrong. And then what we did is that we didn't make a noise. I first wrote a letter to the chief scientist of the British Antarctic Survey, who actually claimed was acknowledged by Laurie David to be helping her. I told him about this fact. His name is Eric Wolf. And I said, Dr. Wolf, here's the situation, would you come out and say that, that's wrong, and then please tell her to correct this. And then I also wrote to Peter Robinson, which is the president of Scholastic that published the book, #1 children book scholar, right? Publisher. Guess what the response is? Both sides refuse to even stand up for this untruth. Eric Wolf was more cordial by saying, she's after all not a scientist, so on. But I say your name is being used here to say that you supply the data. Okay? And then the Peter Robinson one is even more aggressive. They say, essentially saying you're some kind of right-wing conspiracy trying to destroy and attack Laurie David. Remember, this person trying to write a book and misled children and then saying that we are attacking her. She's the one that switched the graph. And then, guess what? A month later, they actually hire another person, a Princeton professor. The name is Michael Oppenheimer. He's actually a very good chemist before. By the way, by coincidence, he also came to my center, Harvard Center, Smithsonian Center for Astrophysics in the 70s when he was doing science then. But this person, Michael Oppenheimer, was also the former chief scientist for environmental defense. As you know, it's the group that is very, very, in a sense that politics is a lot more important than science for that group. So this Michael Oppenheimer now have a position of professorship at Princeton, who essentially wrote a letter like this. Essentially say, we have checked these things, I have checked these things, and they are correct. Essentially the curve has been switched. Okay, so guess who's right on this? We're right? That they have switched the graph. But what makes me really angry about that letter was to say this. But, here's the big but. The but is the worst but that I can see in the history of this kind of communication. Still trying to twist around, but he said, the language and the text that is used, by the way, is very precise to say that CO2 and then temperature, that kind of thing. You can read in detail that books. And then they say, but the language used is all correct to the level in which it should be understandable by children 8 years or older. What that implies to me is, I take it is to say that, well, I can sell you a false product, and then even if you have an error, you should be able to correct it for yourself. Okay? The reason why I wrote to Peter Bock, would you retract all these books and then pay, basically, don't send this book out until you really have it correct and then send it out, right? They refuse to do that. And they send this person I don't know whether they pay him or not, but that's what it is. He come back and say, wow, everything you would do, you say is correct, but children should be able to correct it for themselves.
I'm so sad.
It's amazing. And look at this. This is a small, tiny little incident that I bet that no more than 1,000 people heard me before, but I will keep saying until the day I die, because this is the true fact. I have all those letters, but no one wants to hear it. Laurie David, when he first heard about this, she was very angry, of course. Actually, she did even post something on the Huffington Post saying essentially this is the right-wing conspiracy after her, But it's unbelievable. This is the kind of approach that they are this is their approach towards truth, and then they expect people to stand up and agree with this. And I was very doubly saddened, especially the chief scientist of a British Antarctic Survey, a person of considerable stature, in my opinion. And I sort of know his work and admire his work, and I wrote to him nicely, and they will not stand up. This is where the money gravy train is very, very important, okay? That the result coming from Antarctica has to have some kind of importance, okay? That they're refusing to step off, even when so blatant untruth. And I guess I can only relieve myself by giving a joke like this. Wow, it's not Laurie David that did it. It's basically a cross-eye printers, who didn't get paid enough by Laurie David that just want to purposefully trick her and then switch the graph for her. You're not laughing, but anyway.
I know.
They refuse to back off. And it's just a shame.
What's happening right now with your profession and what your day-to-day is like? What's your life like now?
To me, the joy is, of course, to be able to come to work and then sit down at my desk and then start to think about some of the things that I didn't do yesterday and, try to pursue further. I would say that it's a lot of very unpleasurable things because I'm still very heavily into this research on climate change. So there are a lot of very unpleasant things. I can give you one more example, then maybe I'll stop.
When you stop, I have more questions for you, but I have several things I want to ask you, but go ahead.
Please do. Unless you don't have questions, then I'll truly stop.
Well, that'll never happen because I have endless questions.
Several months ago, myself, David Gates, and then another professor by the name of Sultan Hamid from Stony Brook at New York, I have decided that enough is enough on this issue of CO2 religion, in my opinion, I call it now. And I was trying to say that, well, let's have a proper discussion. Let's scientists take back science because it's only our duty. I do not believe in any politician, right or left, whatever. I don't believe in anybody, any funding, just scientists standing for science, right? That seems to be a very logical thing to do.
Yeah.
By the way, I've been doing that quite a lot, of course, in other aspects. I've been doing that for a while. But for this one, I just fed up enough that I say, well, now I'm going to organize a scientific session in American Geophysical Union in San Francisco in December. So I wrote a proposal, right, to say that we will have this session. And then, in fact, I was so excited because I was able to come up with a rather unique and special thing to try to tie it to Galileo in terms of 400 years anniversary of 1609, where he pointed the telescope to heaven. Then everything changes in a lot of ways. And Galileo, as the master of I guess the first few true scientists who give the notion that science is not about claims or even authority, especially his prosecution with the church, right?
Yeah.
I set him as a very good example. So my title of my session was basically the view from Galileo's window, and then I guess researching the topic, all the processes that are causing climate change in the age of anthropogenic CO2. So trying to make an emphasis that this will be a session that is open to everyone. Science is always open process. We'll have our own invited speakers, and then everybody should submit their abstract to our session. Please join us, so on and so forth, right? But then my emphasis is that this is not about the study about the sun also only. It's about everything else, as I just keep emphasizing to you. I want to be comprehensive, you understand? The sun itself is not sufficient even. So this is why I invited two other co-conveners, which is David Legace and then Sultan Hamid, right? From Stony Brook. David is from University of Delaware. And we had this session, we proposed it, and then the process seems to be normal. At that time, it went through. And then a few months later, we got this happy news. Yes, your session has been accepted, so on and so forth. My God, I was so happy, right? Finally that I can do such a thing. Then they started to say, okay, you should invite your invited speaker now. So I did invite some very, very good people. I would call them, living and walking God, put it that way, in terms of certain areas they are doing, okay, in applied mathematics and physics and all that stuff, relevant to weather and climate. So I invited all of them. All of them agree, and then except for one, even more senior one, was I had to say, please, Dick, his name is Richard Lindzen. He's the finest thinker that we have on this topic. So I asked him, and then all of them finally will agree to come. A lot of work, of course, I have to ask them to accept this invitation. One even willing to come his way from Greece. This is a master of hydrologist too. This person is so prestigious, done so many great work. So I want them to lead off the session, guide the session in a certain way. So we have papers and so on and so forth. So very fine and well. I think by September, we already pretty much get our session act together. Everything is fine, seems to be fine. So everybody submitted their abstract, paid their extract fees, so on and so forth. Some of them even pay for already the booking of the hotel in December and so on and so forth. Then come somewhere in the middle of September or so. First, I get an email from a friend of mine who's from Duke University. He's also proposing a session, a different session, but it's on the sun, right? Under the same conference. And he said, Willie, can you help me? He said. The AGU, the American Geophysical Union, decided to not allow my session because we do not have enough paper. And would you mind if I kind of get all my papers and then some of my paper, in fact, I say all of them agree with my, it fit my team, so I say, okay. So can I get most of my paper coming into your session? I say, sure, why not? It seems to be okay. I read all your abstract, it looks fine, and so on and so forth. And then we also gotten approval from the people in the American Geophysical Union, the people who organize all the session. They approved that, by the way. So it's all done and deal. So finally we have a session that is pretty big size, right? We have like maybe 30, 40 papers, right? And then plus all the invited speakers, right? And then, by the way, I was also an invited speaker. I cannot invite myself to my own session, but I got invited by Nicola, the other person from Duke who invited me to his session. His session is the one that's going to get canceled, right? So he's coming to mine, so now I belong to my own session too. That's okay. Nothing wrong with that as long as we're honest about that, right? So I tell you the whole story. Then, after all of that was done, all of that was transferred, they essentially tell us that, well, you could have a session, but then you could not have the oral session in the sense that you can only present things as poster. So I was already very unhappy with that, and I was really write a few more letters to them begging them, please let me give you a true accurate analogy. To have a poster session in this thing is truly big insult, especially for some of this very
What does that mean? Hold on, we need to explain what you mean. You mean a posted session?
No, it's only a session where you present it as a poster. You cannot have a microphone and talk about it where you have a room. And then, normally you can imagine a scientific conference, a session where you have a room, and then you present your PowerPoint, and then you speak, right? You hold a microphone, you speak.
Right.
But here they have two formats. One is oral presentation, one is poster. But then they only allow our whole session to be poster, not oral. First of all, that's already insult. If it were to be me, okay, I'm still low-level scientist, but not Einstein. You're basically asking Mr. Einstein to come to your conference, your meeting, and then don't allow him a phone and asking him to please present all your chart and write all your thing down onto a blackboard and put it in the poster, and then you stick it on the wall, and then you stand there and wait for hours for people to come to talk to you. I mean, it's ridiculous, first of all.
Who is the AGU?
It's American Geophysical Union. It is the world's biggest earth science-related sort of union, okay? And I begged them, they wouldn't budge. And then worse yet, one more week later, they come. Now they come and write this. They say, well, we checked all your papers, and they look like there are so many different disparate themes, because some people were talking about the sun, some people were talking about the clouds, some people were talking about the flooding, the water levels, some people were talking about the Arctic. But remember, that was exactly my theme, right? To be multiple disciplinary, right?
Right.
And that was written in the language that I wrote for the proposal of the session, which is printed, by the way. And then now they say that, well, your session is so disparate in different theme, and you didn't have a theme. So now we're going to create one for you. They basically kill off my whole session, rearrange everything, and we're going to have another session that is just purely on the sun.
Why are you answerable to them? Why couldn't you just gather people together? Why are you beholden to any agency?
Because this is the place in which you have a forum to have a proper scientific discussion, isn't it?
Well, obviously not.
No, obviously not. No, what they did is that they basically disabandoned my whole thing. After so many months of working this, and then they even cancel, basically, take our pieces. They would never admit that, of course, that they have dismantled my whole session. And then this basically show you how much power they have. They control everything, right? But then it's just not right to do that. I have done everything properly and correctly. And then they just come in and then choose what they want to choose, what they do to me and my fellow convener. And all this communication, they didn't even bother to copy my two conveners. I was so mad also. They treated them like a piece of junk, that because I'm at Harvard, that I'm somebody special. Not, obviously not. These people are my equal because we proposed this thing together. Although I was the lead in that sense, of course, but it doesn't matter. In science, you share just about everything when you put your name together. So it's really ugly. In the end, of course, now the bottom line is that they cancel everything, and then 3 of my invited speakers refuse to go now, of course. But we no longer have my session anyway. So I am probably going to this thing for the last time. And as my young career, I'm very sad in that sense. Because guess what? I'm so young into the game, I'm no longer willing to be going to this, because it's just a pure insult, to try to deal with this kind of nastiness. And they would never say they are sorry, of course. They would never. It's all matter within their right to do it, of course.
Well, your hands are being tied so that you cannot conduct true inquiry.
That's what I'm saying. And it's a very, very strange situation. And here I'm doing it for the public good, for the science group good. It's not about me. It's about how we can advance the science together. This is why we need that forum, you see. If you can make your own conference, for example, right? You know that maybe there's a conference by the Heartland Institute, which I love dearly to go. They invited me, I go. And then they label them to be some kind of right-wing thing, then you have less credibility. Here, remember what I was telling you, I'm doing this scientist fighting back for science, right? So I wanted to do it this way, and then all of a sudden it didn't even get started. I guess the show hasn't even got started, it's already ended.
But maybe, maybe the silver lining of this is that this true dialogue and true inquiry and synthesis of historical information and discovery is supposed to happen under a different context and umbrella where free thinking, free thought, open inquiry, and contributions on a whole systems level can truly happen. Do you know what I'm saying?
Yes, but it's obviously a very, very impossible thing. I mean, it's just very difficult, especially for such a organization. By the way, this organization does have the position statement that, man-made carbon dioxide is damaging the earth, so we have to do something. I mean, they have done a lot of this inappropriate thing, in my opinion, even as a science organization, where, it's obviously the signature of that position statement was basically the upper echelon of the group, but it doesn't. Even though I'm one of the members, but I certainly do not share the view. This is where now this day, all this big scientific organization is no longer representing science even. They're representing the interests of the politician. I would even go as far as the view of Al Gore, for example, because it's highly praised. The man is basically a walking god for them, where he has not done anything worthy or even close to something useful for science. In my opinion, he has done a few things. For example, allowing the Russian to share their Arctic data with us, so we know a lot more about the Arctic Ocean. As a politician, he has done some of that kind of thing. He's not totally evil, we know that. But then still, how come free science inquiry could not prevail? That's the bottom line that kind of bothers me quite a lot. Which of course, I'm not complaining. I'm just simply saying that, look, these are example after example of that sort of madness and insanity that's going on. That is truly bad. If we don't let people know more about this, maybe there will be some impact. I don't know. People should be able to say that, hey, what you politicians should do is basically that stop interfering with science. That's it. You should fund science as a basic science, and then instead of just always tagging along with some price tag, you can only do this if you're going to promise this super duper nonsense. They're actually basically tagging along all of that now. This is the way now actually all over the world the science is being done. If you propose something, you got to talk about the consequence, the outcome that you're going to get, that is beneficial to society and science, which in some areas is certainly true, of course. But in most of the basic science that we really need to get done, to have certain breakthrough in our understanding, just could not have that kind of prescription.
And that's why you have to have a different kind of financing capability. See, in my view, there's no shortage of money in the world. What there's a restriction of or limitation of is the consciousness and the mindset and the paradigm behind the money. Millions and millions of people are trying to raise money for things they want to do. Mm-hmm. And they constantly chase capital or where they think capital is. And I tell them, you could do that till the cows come in. You have to make sure that the consciousness and the mindset and the paradigm behind the money is a fit for what you're trying to accomplish, because otherwise you have an oil and water mix. It doesn't matter. It's literally the frequency behind the money, kind of like we were talking about the oceans have an alkaline or an acidic base. Money is the same thing. There's an alkalinity, acidity, consciousness behind money. So, for example, I'm just sharing this with you, if many of the universities in academia in general has been co-opted or polluted and is acidic in its mindset and paradigm, the way that it works to obstruct true discovery, it means that you have to set new ventures in motion with a different kind of funding from totally different methods and means, and be willing to not count on and depend on money coming from groups and institutions that are co-opted, have a political agenda, and will tie the hands down of true discovery.
Very well. I fully accept that point. I can give one more example in my personal experience. I know a person by the name of Arthur Robinson. He's really my personal hero in science in a lot of ways. He's at a stage today that he's no longer willing to take government money to do scientific research. All his money now that he's doing, great research, groundbreaking work, okay, is done with his young kids and great kids, by the name of Noah Robinson, who finished Caltech chemistry PhD in 3 years. Really brilliant kid. They're doing really interesting work on molecular clock, okay? Essentially the idea that big molecule of certain kind of protein can remember time. It was his pioneering research. He has things that is running for $2 million now, all from private donation, by the way. He wrote a newsletter called Access to Energy.
What's it called?
Access to Energy.
Access to Energy.
Right. And he done all kinds of things, of course, homeschooling, that kind of stuff, homeschool curriculum. But just to give you a background of his brilliance is that, he was handpicked by Linus Pauling. Linus Pauling is among the few who have 2 Nobel Prizes to be his first director of the Linus Pauling Institute. And then he, of course, have a very sort of violent parting way with Linus Pauling, because as Linus Pauling gets older and older, he tends to want to go into the direction in which where he wants to say that vitamin C is the miracle cure for all. Right, where he emphasized that you have to take a lot of vitamin C, to the point where Art Robinson was also interested in the question, so doing those kind of laboratory experiment and so on and so forth, but to the point where he's actually, when the data is not going the way, he's trying to force kind of cajole Art Robinson to go that way. Art Robinson is a true scientist who would never do that. So when he refused to do that, you can see the consequence, right? The situation. So they parted way with lawsuits, so on and so forth. But Art Robinson is also one of those people who is capable. For example, he gave me an example in his experience. He knew, for example, how to make an analyzer a long time ago, of tracing chemical elements in blood or urine, for example, that could, let's say, test, 1,000 of the elements at the same time.
Wow.
But nobody wants it. all the companies, all these big technology companies, is not about saving life, honestly.
I know.
At that time, they kind of want you to have a machine that can test one at a time. This is where the disgusting about how goodwill turned into a really totally ugly thing that I got very angry about too myself. But I'm not his caliber. That's the whole point. So he's a very independent person. Now he's pursuing his research that way, quietly. Leave me alone. He's just doing his own science now. I mean, I'm to the point where I could go that route because I'm just tired. This is not the way to do science. I would never go back on science, of course, because ultimately this is my life, the whole thing. I always loved science ever since I was a kid. And I always wanted to learn science. I never doubt in 1 minute to try to cheat or tell anything untruth. Anything that I tell you, if it's untrue, please come back and tell me that, okay, you say this and this that is not true. Then I will check the fact. If I'm wrong, I'll tell you, Kim, I'm wrong. That's it. It's that kind of clarity and truth that I demanded myself. There's no way that I'm going to put out something junk, like this. I'm not willing there to gain something for one day or something. It's all for permanent, for something that is truthful. And this is why when I see science is being manipulated in such a way, it's just very intolerable. And then, of course, this is why I told you that last 5 years I've become very active. Anybody who wants me to speak. I mean, one time I was at my own local Salem State College over here where I live in Salem, Massachusetts. Some Republican group is asking me to speak. I don't care, of course. If the Greenpeace asks me to keep, please I'll go. But of course, somehow they never invited me, of course. But I went. There was maybe, I would say, 6 people, in the audience. I'm more than happy to even be able to reach 1 people. That's fine, And in it, 6 people is basically those people from the club. And then there were 2 professors from the Salem State Geology Department. They are basically believers in CO2. What they were so worried about is basically these 6 people are being, I guess, indoctrinated by my power of persuasion to talk about global warming. And they were in there constantly interrupting the talks, constantly trying to not let me talk, even to 6 people. I was just fairly amused and somewhat saddened too. What are they trying to do? What are they so afraid of? To the point, actually, in the end, maybe 30 minutes later, he said he got mad, and then he started to say, I'm not, because I keep answering him questions. He started to get mad. He said, I'm going to deal with it. I'm going home. Okay, please, do what you like. The whole thing is completely open, but they were so worried about 6 people getting indoctrinated by Willie Soon. What I'm trying to tell you is that I'm willing to work as hard as I can, as far as I know, in terms of reaching anybody and do the best I can. But their strategy has always been very strange, in my opinion. It's always been about, even 6 people, they are worried, But this day, of course, I get more and more audience. Last year, I was able to talk to 1,000 people, for example, in the International Geological Congress in Oslo, which, by the way, is not a very fun place to go if you're not Al Gore, because the beer there costs $15. It's just way too expensive. When I spoke there, for example, to that big group, I talk in smaller session, of course, but I was also invited to do the main one, right? Where they have they pick 10 speakers, but maybe I was the only one that is basically against the CO2 idea. So this is the typical, what you call, I don't know what you call this, but it's like a small little prize, that they cannot have it all too one-sided, so they have to pick one guy, right? So I'm just glad to be the one to be able to talk, right? So I go there, I do my talk. Same old thing that I keep doing what I'm doing for all these years. In front of it, and I criticize the United Nations Intergovernmental Panel on Climate Change report, right, which everybody says is supposed to be the Bible, because anybody who say otherwise is crazy or wrong or corrupted or what have you. But I was criticizing point by point the problem there. And sitting in the front row actually are those authors of the IPCC. They are the one that get to speak also, of course, before me, right? And at the end of it, of course, I just politely asked, please, question, right? There was absolute dead silence. No question, by the way. But out in the middle of nowhere, there was this guy shouting, become totally angry. How dare you criticizing IPCC? I'm one of those IPCC representatives. I work with IPCC. I know IPCC is a scientific organization, so on and so on. I said, no, it's a political organization. He was essentially, and then, of course, in the end, I just asked him, sir, do you have a question? You don't have a question? Oh, okay. Thank you very much. Please have your comment, of course. But that's the way it is. That's how they react, It's never about what is it that you say that is wrong or anything. It's all about shouting and all this stuff, it just blew my mind, actually. Time after time, no matter how many times they do it, it's still always a funny feeling, Last week I was at Google at New York City. I went to New York City for dinner, but then I know a friend at Google. He said, hey, come and give a talk. So, okay, I'll give a talk. Google, as you know, is very into this business of renewable energy and all that, right? Mm-hmm. Fine, I say, if you want to pay for it yourself, go ahead and do what you want. But I just talk about CO2. I just simply tell people about what CO2 is not and is. And in the beginning, there was a person there, of course, obviously, by the way, before I even go there was already a circulation on their Google internal list. The chief environmental officer, who is based in Mountain View, was already spreading around, essentially tell people, don't come to this Willie Soon talk. He's so corrupted and oily that he's fully funded by ExxonMobil, so on and so forth. Before you even go there, okay, it's already that kind of nonsense, you know. And I'm glad that there were some people there, of course, so I spoke. But then in front of it, there was actually a guy who physically wanted to keep challenging me. But I was happy to say that, you know, he kept challenging me for the first 15 minutes, but after that I keep answering him, and then he sort of sit down, calm down, and listen. At least let me talk first, you know, and then later we can have a discussion. What have you? I say, I'm willing to stay as long as you like. I have the whole afternoon. So ultimately, the process could went smoothly. What else can we do? Yes?
Yes, you're doing what you're called to do. I have a question that's off the track now. It's really off the track. If you're not comfortable, don't answer, obviously. In all of the trials and tribulations of you trying in every way that you can to stay a true scientist in the field of open, true discovery, have you gotten closer to maybe wondering if you're supposed to stay in academia? Are you getting the sense that you may need to be outside of academia on a formal level in order to not only potentiate, but to manifest true open inquiry and discovery so that you can really fly with the things you really want to find out?
I think my quick answer is basically yes and no, both, because it's just basically my own personal outcome, you know, my own personal style and things like that. I very much enjoy where we are. Actually, I would not be here if we were to not for the level of access in terms of library. I mean, give you an example. When I do my semi-popular book, my recipe was basically every weekend, Saturday and Sunday, say goodbye to family and just come and do work in the library. For a year, roughly. 52 weeks, that kind of thing. It's enormous. I mean, I was touching basically Winthrop, you know, John Winthrop, the governor of Massachusetts, you know, in the early days, the 17th century, that kind of document. I mean, you know, it's just, it's a paradise, okay? When you come to a right place I mean, this is part of the reason why when I first came from California that I didn't go back to California again. I mean, came here in 91 and then I started to stay here and it's just very enjoyable. First thing I was given was a key to the library. Unbelievable at that time. To have a key to a library, it's a small library, it's our own astrophysical and physics library. But it's perfectly good enough for me. So I was extremely productive in the early day, of course, when you don't have family. I mean, it was a lot more, you know, really pure and essence of joy, in my opinion. I mean, you can call me strange, but I really do enjoy seeking knowledge, you know, asking the right questions. So this is my own kind of style, which is why academic is still a very nice place for me. Lately, I also felt a strong sense of communicating, you know. I don't know why, I just felt like I just need to talk. I didn't need to tell people what it is. More and more example, by the way. That was just a few little things. But I just felt that the yearning to try to talk to more people. I ultimately will actually, I would say that I would go towards the area of teaching, you know. Maybe it would be going outside, you know. I do felt the need, of course, but I don't feel I'm too blocked right now. But there are many things that I hear that it's just, you know, best not said. I mean, I have, for example, a professor from Australia attacking me and then I'm not supposed to respond. Just for the sake of not giving further ammunition to them, according to them. But think about who is offender first. I wrote some article in Australia's magazine and they were unhappy with it. The reason why I wrote the article was professor in Australia was telling lie, and then they have another professor attacking me now, writing to my director, essentially want me to be fired. Can you do something about this, Willie Soon? He's ruining the reputation for the Harvard-Smithsonian Center for Astrophysics. And then that letter now was left unanswered. I already prepared an answer, of course, But essentially, I was told that it's best that we don't do this, but no one can stop me, they say. I leave it in the sense that I do not want to answer for this simple reason, because the thing was, the weight was too strong. My center is really a fine institution, but again, after a while that I think about it, it sort of doesn't stand for nothing if you don't stand for me, for example. To even write a cordial letter to try to challenge this guy back. What is it that you say that is valid? Because he's just, his letter is just ridiculous if this thing is being shown to people. I'm sure of that, okay? But the problem is still that, this is the kind of a thing. Yeah, I'm doing research, blindfold, hand tie, leg tie, what have you, Essentially, someday somebody will take the oxygen away from me. Maybe that day I will live. But I'm that stubborn, I'm that resilient in that sense because I just enjoy doing what I'm doing. And I felt that, in basically a place like this is still a very fun place. This is the place in which I met some of the most brilliant people that I've ever imagined meeting. But this day, I can imagine even on the people on the street, you can find some really brilliant mind too.
Do you think that astrophysicists and physicists in general are receptive to God?
Receptive to God?
Not to religion, but receptive to maybe divine intelligence?
Correct. I really think, yes, there are large people. In fact, most of them are a bit afraid, kind of scared of this thing because they are afraid of being labeled as, I certainly are very, very close to God, although I'm not totally committed. I mean, my best friend, Art Robinson, which I felt it's impolite for me to ask him. I always ask him, please tell me. And he's very close. He's like my father to me, so I was able to ask him that kind of question. And he said, this is all personal thing. Let's not even talk about this. This thing best not be talked about. And then you just have to read the Bibles and read all this great literature and then, synthesize it for yourself. But I have enough influence of the people who truly, have a commitment to God that you can say maybe part of what I'm doing is basically my own way of dealing with God. I kind of come very close to, of course, God, but then I'm still not yet totally committed.
No, I understand. I just more meant it feels like in listening to you that you are constantly being challenged spiritually to stand in open inquiry in the domain of true discovery, and that it takes spiritual maturity to stand continuously in that which is true up to the forces of darkness, the forces that are trying to confuse and obfuscate the science and obliterate the science and tie your hands so that you can't inquire openly. And it just seems like now it's both a spiritual quest to stand true to your work and your calling. You're passionate, so that means you're deeply connected to a deeper part of what you're doing, which means you're doing what you're supposed to be doing. To me, it sounds that way. But I would imagine in the quiet times of your life right now, in more of an energetic sense, you're closer to a divine intelligence or to a higher power, or to whatever we would call God, than probably ever before, because you're having to be and stand in such a strong, deep place that only a person of a deeper faith, and I'm not talking religion, but just a deeper faith, could do it.
I wouldn't deny that. I would just interpret in lesser sense. As I try to tell you that I truly believe many of my fellow people that I admire, for example, physicists and mathematicians of all kinds, it's actually very strange. The one that come sort of very close to me, right? I can give you an example. David Gates, for example. He's a full Christian, right? And most of the people that I know actually sort of put their faith in God already, a lot.
Yeah.
And these are all people who constantly, daily dealing with some very beautiful questions, I mean, to me, God would be the ultimate beauty, maybe.
Yeah.
But I'm still, like I say, I'm not too because I'm struggling very, very hard, of course. And I mean, I struggle even harder, especially my father passed away 2-3 years ago, that I was, my compass, was kind of switched around quite a bit. And I was asking different sets of questions, of course, at that time. I would say I think less of that issue, by the way. I think less consciously about those issues. The peace and quiet that I get is when I read something. This is why reading is ultimately the pleasure for me. I mean, not watching TV or not anything. Reading is always the most ultimate pleasure, in my opinion. And when I read something in Bibles and all those things, I felt certain detachment still,
Yeah.
My God is basically more like a living thing, like the action, the looking at people, interacting with you, for example. I mean, that kind of thing, on dealing with my fine mathematician things, when you look at the kind of thing they do, it's just, man, how did they come up with that one? I mean, some of the things that people can come up with, the human mind could create to fit this physical reality that we know.
Next week I'm doing a show with Paul Smith, who was part of the military's first advanced data collection project.
I see.
It has to do with transcending time, space, and matter, going into the past and gathering data, and it has nothing to do with clairvoyance.
Mm-hmm.
And we will be speaking about time, space, and matter, and how the data collection process and procedure was taught to his team.
I see. Very interesting. But I mean, I can personally tell you that the thing that I feel certain reward is to be able to communicate to my dad and actually my own uncle too, who's living in China. But the reason why I mentioned that is that because I was born in a different land. I was born in Malaysia and I came to America to school.
Wow.
But I was most proud that I was making every effort I can. Ever since I was able to understand a little bit about physics and especially the mathematical, sort of a bit of physical explanation of black hole, of space-time anomaly. I mean, you could not imagine how happy I was to be able to kind of talk for hours and hours in the afternoon drinking tea and trying to explain to my sick uncle who's about to die. But to keep insisting and make it a point that that's the discussion. I want to explain, I want to convey the beauty that I felt, that is so beautiful. And he certainly shared that. Remember, these are the people who just never gone to school.
Right.
And my dad is another amazing character, right? Who never gone to school, but he just have the natural brilliance, the people kind of person. He has a human touch that is so amazing, that I admire so much. He essentially doesn't know how to build a thing, but then he's this successful builder who can make millions and millions of dollars just like that because he's able to convince someone to do some work for him. And then he shared the wealth with them, of course. But I was just very, proud of who he is, But anyway, it's just another strangeness. I was very happy to make sure that we can talk a little bit about cosmology and then question that cannot be answered in a lot of ways. And then black hole was one of the things that I find it extremely strange that they ought to be, at least discussed and explained as best as we know how. You can find far out field that people were still discussing about different way of interpreting black hole, but that's another subject, by the way. I get even more exposure when I actually become an editor of a professional journal called New Astronomy. I mean, we constantly see all kinds of crazy papers sometimes, but I'm one of those open-minded editor, mind you say, to give people benefit of doubt, by the way. Now I have a real problem of one particular paper that I could not discuss, but it's just very interesting. It was talking about certain symmetry principle that demands some really good mathematics to understand this. Obviously, the person has been rejected all over the place, by the way. And then somehow he came to me, and then I started reading it. I say, this kind of discussion seems to be honest, seems to be, very mindful, and should not be just rejected outright. So I didn't want to reject him, so I started to look around for the best friend I can find all over the place. Please, let's try to see whether this, but you still need some kind of review, of course, to be publishable as some form of discussion, a paper that would further stimulate thoughts or somehow.
I have another question before we close today, and I want you to know that I've learned a lot from you, and I so appreciate your dedication to the truth and to keeping the integrity of science intact, and for standing up to political and financial forces and prominent people and institutions in order to keep the integrity of your work. You're a physicist as well. Can you explain to the public what a vacuum is?
Vacuum certainly has a lot of a notion in which that is purely a spatial thing. But I really think that vacuum, well, first of all, let's just talk about what we know as a vacuum in a lab, for example, You just basically try to reduce the amount of stuff in it, in the sense that if you have a billion times of a number of molecules in this volume of air, you just want to reduce it to zero. That's it. The thing is actually filled by no physical entities or material in it. But I felt that if you expand the concept of vacuum, it certainly should include time as well. Because after all, we know about this space-time business. maybe I'm not the best person to answer that. In fact, I think it's a very hard thing to answer. It's a bit like searching for inertia in Einstein's sense. One could not find this framework because talking about vacuum in absolute sense, it doesn't exist that way.
I think an entire show should be dedicated to communicating what can be known about what a vacuum is, because I have a feeling, I'm just going to say this to plant a seed, I have this notion that to the extent that people at an individual level can be part of understanding how to create a vacuum in their everyday circumstances in the solving of problems, which means to allow for empty space, to ask a question and then allow for empty space, not have to fill the question immediately, to hold the question and contain it, creates an energetic vacuum out of which the cosmos, so to speak, or information can flood in that's both intelligent and also in the natural world. And so I have this sneaking suspicion that there's a way to ask questions, contain them, and allow for the information and input to come in of its own time while you're holding the emptiness of time and space with that question. Something connected to containment. Asking a question is not just a conceptual phenomenon, but an energetic phenomenon that translates into the realm of physics. It's almost like its own alchemy.
It's interesting you say energetic vacuum. That phrase caught me.
Yeah.
Yeah, I mean, this is why I try to emphasize that. I mean, vacuum should encompass something about the time too, but it seems to be in a physical sense. I mean, in the way that we understand in the lab, when people say they do a vacuum, it just pump air out, right? Try to suck all the air out and try to leave as little as possible.
Right.
The only thing that keep the whole thing there is, of course, is the container.
Right.
What else is in there? Does that mean time is stopping in there in a vacuum? I mean, really, you're right. You're leading to more questions.
I guess what I wanted to share with you that's part of my work is that I see clearly that there is an art and science to question construction, asking questions and asking questions in a way that creates a vacuum.
Yes. I think you are maybe getting closer and closer. I mean, it's very interesting. Yeah, I mean, I see now. You're not a physicist by any sense, right? I'm sure you study some physics.
I'm not a physicist. I don't claim to know anything. I just know that I've watched time be compressed, a phenomenon where things happen faster and things can come into manifestation quicker when you get one or two people containing a question, and then you add more people who ask the question and contain it. Sets up a magnetic, almost a causal, resonant field to get the answer, which is already out there somewhere, to come into the field. Does that make sense?
Yeah, it's interesting, all I can say.
Well, if I've got you thinking, I've done something good.
No. Well, I think it's a worthy of a struggle, and I think we should keep struggling.
Well, I'd like to have that conversation with you at some other time. I really want to thank you.
No, thank you for
today.
letting us at least spread some information, because I think that maybe it'll do some good.
Thank you. Yes, people often tend to think that I'm a broadcast host, and that's all I do. But I've been on a mission for 25 years to establish an international solution delivery network and to bring forth a new paradigm for the introduction and the delivery of solutions. And in order for that to happen, you have to have people that are committed to true discovery.
Do you think then you essentially, the more people you interview, right, you essentially are sort of, are you spotting some talent? Are you telling me that you are spotting some reasonable minds? Just kidding.
You know what I think? I think that the beneficial, benevolent, positive, life-giving breakthroughs and discoveries, which have to do with making life better and enhancing the quality of life, is a casting job.
Yeah, it's a bit like that, isn't it?
It's about being able to identify the people that are receptive, that are humble, that are excited and passionate, that are open to true discovery, and want to coalesce with others like them for greater and greater goods, services, businesses, opportunities, knowledge, information, and that by bringing people together, like on its Rainmaking Time, we're laying out groundwork for breakthroughs and discoveries for people to be able to run with them. We're planting seeds so people can run with some of the most groundbreaking, exciting work of the modern day. And of course, as pioneers and visionaries and people that are on the edge of true discoveries, you face persecution, but it's also extremely exciting. I want to thank you so much on behalf of It's Rainmaking Time, Willie Soon, from the Harvard-Smithsonian Center for Astrophysics, and all the work that you've done. And we look forward to having you back with some other folks where you can speak freely. Thank you so much.
Thank you, Kim. Bye-bye.
God bless you.